position of Proctor, Security Officer, and Deputy Director, Center for International Cooperation in University Administration. Recently, he had worked as visiting professor in Tokyo University of Science, Tokyo, Japan, and visiting scientist Raman Fellow in University of Puerto Rico, Mayagüez, USA for 1 year. He has also visited Germany, France, China, Boston, and other countries, presented his research paper and other academic activities. He has supervised 6 PhD and more than 35 MPhil students for their research thesis. He has published more than 45 papers in reputable international research journals and serving as a reviewer of several national, international level journals of repute. Recently, he has been nominated as an editorial advisory board member of Vigyan Prakti, published by Niskayar, New Delhi. Welcome, Professor Birpal ji. Please start. Welcome, sir.
Thank you, Dr. Thank you from Radhabad and chairman of this international e-conference. Dr. BBC Chairman and Dr. and Misty, conveners of this international e-conference, Dr. Anil Kumar and Dr. Rakesh Kumar, and all other learned members and officers of organizing committee, especially organizing secretaries, Dr. Dalip Kumar, Mr. Sundar, first of the conference. Of COVID-19 pandemic. Now, let me start my presentation. The topic of my presentation will be smart material that will somehow related to metals as well as materials. I plan my talk in 3 parts. In first, Chaudhary University, quickly in few slides. After that, I will, for general audience, I will discuss something about nanomaterials. And in last part of my lecture, I will discuss the objecting and materials which we really work in our laboratory. As far as my institute, I am from all university, and for us that colleges that are affiliated to university, and more than 8 lakh students are regularly studying in. This is all about my department of physics. In department of physics, we are running MSc course and experimental activities we have. We have clean room facility with optical mass wafer with photography data. We have IECEAMPS scanning lab. जी डॉक्टर साहब जी हेलो
Continue, sir. There is no problem. Hello.
okay. So we are you getting my voice?
Yes, getting, but there is some connectivity problem, sir. Little bit, but it's okay. You may
Oh,
continue, sir.
okay. So we have AM, we have SM, we have AFM, etc. And in addition to that, we have number of instrument for nanomaterials in magneto sputtering system. Department is science, good equipment facility for lithography. This is that's which let materials as well as and of art of that kind of materials which we have in our laboratory. If you see the material science and nanostructure materials, it is a hottest field of research and development for physicists, for chemists, for biologists, for engineers, technologists. Simply, you can say this is really highly interdisciplinary. It's a highly interdisciplinary subject. It's a property relationship of the materials. And ultimately, in case of material science, we deal with 4 parameters. One is processing, second is texture, third is properties, and function of materials. Function of materials means the performance of device. In general, we all the times bother about the performance of a laptop, that may be the performance of paper, whatever that is. So be tested all the time. It really depends upon the properties of the material which we use in particular application. That really depends upon the texture of the materials, and the structure of the material simply depends how we process the material. Times what we are doing, we are simply processing the materials, checking the structure, and knowing the properties, and ultimately apply the materials for specifications. So these are the 4 key points or keywords of material science. Engineer, mechanical engineer, whatever science. Now, as I told you, material science focus on nanoscale material, or simply in 21st century, we are working and of nails. we study the materials at nanoscale, and at nanoscale, the property will depend upon size of the material. Ultimately, in life, we are anything that material, what materials, what act you are purchasing. So you can say material utilization is purely a selection. Okay. My slide is my okay. This is all about the nanoscience and nanotechnology. Is a issue. It's so that the word seems small with that issue. And in general, I used to speak three terms in this particular nanoscience and nanotechnology: that small, faster, and better. And sometimes I call that nano mantra. And what that size will be small, be a nano is then is 9. The object, if you see nowadays, we are having COVID-19 or coronavirus. So the size of virus is again changed. DNA, we all have DNA. DNA again having the size of nanometer. These are the objects which are really having the size of nanometer dimension. Now, just to realize nanometer dimension, if we comes in, then the dimension will be 1. Now, if we bigger than on to complete dimension, I realize different objects in dimension and that here is and DNA. So was disc June Almedia, and uh, he in 90 in that virus by using electron microscope. And electron nanotechnology. We can claim that people are doing nanotechnology all the way, all the times, that we can say.
Sir, excuse me, sir. Hello, Professor Bipal, sir.
Even nature or insect. Yeah.
Hello, sir. Sorry, sir.
Yeah, I am listening.
Yes, sir.
Hello.
I think your bandwidth is very low. Please off your video and the presentation must continue. Off your video and lecture is continue.
Okay. I'm opening. Okay.
Yes, yes. So
So
then it will bandwidth
uh,
will increase little bit.
this is in this, okay. This is in this. Okay.
हेलो सर, आवाज अब और भी कम हो गई, पता नहीं कैसे। हेलो
Hello, Sundar sir, please continue.
Professor
Hello.
Birpal ji. Hello, sir.
Oh, hello.
Oh, are you hearing me, sir? Your voice is not clear, sir. Actually, I think there is
Oh,
some frequency bandwidth problem there.
okay.
Try, sir,
So
try.
okay. So this is all about how materials property are different in case of nanomaterials. Melting point change, lattice constants reduce, bulk semiconductor become insulator, and ferromagnetic materials may become superconducting in nature. Slide change नहीं हो रही भाई. Textures, and in this you are set to confine dimension, property will change. Then that will become that will become and terms of nanoparticle conclude that nothing at least see how, and as per their geometry and structure you can give name of that kind of structures. That may be nano ribbon, that may be nano wires, that may be nano cylinder, whatsoever etc., etc. And as far as concerned, in that case, you can nanomaterials by two approach. One is scaling down, bottom up, simply the manipulation of atoms or molecules one by one. This is all about the material that iron has difference, that has FeO, that has Fe3O4, in which you have mixed valent compound. Iron will be in three states, that is alpha phase or alpha gamma phase side, and the very typical job to control the phase of iron oxide. In our research, we control the phase of iron oxide, and we successfully synthesize Fe3O4 compound of iron oxide phase, and we use these materials just to sense a very important drug that you called paracetamol or acetaminophen. This is all about the characterization of magnetite Fe3 called hematite of is nano. We characterize the material by using XRD, and we calculate particle size by well-known. Just to confirm that either there is of Fe3O4 to alpha Fe2O3 phase, we did TGA and DSC analysis for that, and we did Raman for that, and ultimately we conclude that at higher temperature, if we heat the material 3O4 to approximately to alpha of iron oxide, and we confirm same thing by TGA and DSC. This is all about the application part of iron oxide. In our case, we use that particles alpha and gamma for electrocamically sensing of a very important drug that called acetaminophen. Acetaminophen is simply your calpol, or which you have your fever and for pain. No, acetaminophen, it doesn't show any harmful side effect. But if we have overdose of particular drug, it may cause very and all. So it sensing of this is very important. Initially, people used to have chromatography and spectrophotometry, liquid chromatography, and electro spray mass spectrometry and spectrophotometry for sensing this particular. In our case, particular by and very simple and as well as it's biocompatible also, because iron oxide are very biocompatible of iron oxide, and in that case we simply modify working electrode of 3-cell electrode, that was the glassy carbon, by our iron oxide nanoparticle. And if we then we found electrical you are seeing in current, and we basically confirm that our material is electrochemical that able to sense drug electrochemically, and the CV measurement of acetaminophen at different concentration, and ultimately we sense this particular drug up to 10 molar concentration, and then we plot a curve in between current by that we can say that one can electrochemically sense this particular drug using electrochemical and in that we are 0.98, very close to 1, and ultimately this r square value will decide what kind of variation in current and so in that case we are seeing the level in action. For that we experiment we as well as we change the scan rate just to know about in scan rate. We found that the process here was the diffusion constant for that, and these are ultimately the parameters. The linearity was quite good, as I told. Concentration range 3 to 10 to the minus, and the quite good, that 30.6 microampere per millimole. So that was all about the sensing of acetaminophen by using iron oxide nanoparticle. Use particular material iron oxide just to sense difference, and that's the H2O2, hydrogen peroxide. And again we have very interesting result in that, and we found that again electrochemicals H2O2, and we publish these work in few in Materials Research Express and in IECEAMPS journal of CSIR. That was the first part, and in part few materials as zinc oxide as well as MOS2 for TFT, thin film transistors. Thin film transistors are really very important kind of device in solid state, that has very electronics, as we have application in mobile phone, in LCD sensors, in smart car, RFIDs, etc, etc. Now in that the very important in style we style for different purpose, and it's a very new application of that kind of TFT. And we use synthesize the thin film of wide doped zinc oxide. Ultimately of thin films for thin film transistor, and successfully we fabric TFT. These are about the surface morphology and the TFT characteristics of our wide doped zinc oxide TFT. This is all about MOS2. MOS2 is again a very important and very advanced material, and that may be the replacement of graphene 2D materials. And one of my students, Miss is working on that kind of material. She synthesize for TFT, fully fabricate TFT device using MOS2. And maybe in next session, technical session of your conference, she will deliver the presentation on MOS2. This is all about again in that case.
Conclude, sir.
And of surface volume and all as absorption spectra band doped in zinc oxide, and ultimately we use that for photocatalytic degradation of methylene blue, and we published that work in Solid State Science recently in 2000. In next copper oxide and in this copper oxide nanoparticle we dop by transition metal MnCO, and we have very interesting result in that at very low concentration, even at low concentration, we found and the sample XRD by XPA and by Raman and by PL, etc. And ultimately, we found that there is a phase transformation. In that case, even at small concentration of spin glass observed for Mn.CO samples. This is all about the different application of copper oxide for the deposit copper oxide thin films, and we use sensing of hydrogen. And this work is a process. These are the initial results of that kind of work. And ultimately, I should conclude synthesize Fe3O4 magnetite, Fe2O3 hematite, and gamma phase of magnetite, Fe3O3 iron oxide nanoparticles. And we found that these particular materials of different phase of materials to prepare hydrogen peroxide. Or simply you can say you and just to monitor or sense electrochemically the different drugs molecules. These results suggest the use of iron oxide is an excellent electrode environmental as well as in pharmaceutical fields as an alternative for the analysis of pollen. Iron oxide is a biochemical material. So you can say that that kind of materials may be useful in medical field also. And the white doped zinc these are important just and materials. Zinc oxide, we kind of material that kind of Al doped zinc oxide is a photocatalytic degradation of methylene blue oxide. Last hydrogen gas as you in that was all about the applications and the conclusion of our research which we are doing at our laboratory, and number of students are working on my students. These students thank you
Okay, sir. I have a question, sir. Professor Birpal ji,
thank you.
I have a question if you are hearing
I'm
me.
hearing your voice.
What synthesis method for,
Please
sir,
go
what
ahead.
synthesis method for nanoparticles you have used?
We are using basically co-precipitation method, chemical method, bottom up approach, basically co-precipitation method. Mostly we are using that method, and some students are working on hydrothermal synthesis of iron nanoparticles. And one very important method we devise in our laboratory by using IR radiation without
Infrared radiation.
any stirring, without.
Okay, sir. Any question from participants?
Thank you.
Thank you, sir, for very nice and informative lecture.
No,
Dr. Rakesh.
I think it was session. Bandwidth was not
there is a little problem.
so good to listen me, I think so. Yeah. Thank you anyhow. Thank you.
Thank you, sir.
Thank you all for inviting me to present my.
Okay, sir. Dr. Rakesh Kumar ji, please come.
Yes. Thank you, Dr. Anil Kumar ji. Now I will call Dr. Tarun Kumar Garg, Associate Professor, Satwati College, New Delhi, and he is Associate Professor. He has done his MSc from MDU Rohtak. He has published 11 papers in national and international journals. He has worked on his own work on wavelet analysis, and I request him to present his lecture. Please allow him to share, Dr. Sundar Singh, to share the screen. Dr. Sundar Singh, please allow him to share the screen.
He is able to.
Yes.
Screen.
Hello.
Sir, continue. Tarun sir, please continue.
Okay.
Yes, thank you, Rakesh ji, for inviting me to deliver my talk here in your conference. I hope in this time of Corona crisis, all of you are doing well with your family. Now, I start my talk here. I would like to share my screen if you allow me. Is my screen visible to all?
Yes.
Yeah.
Yes. The talk of my conference today is the reliability of skim milk power production system of a dairy plant. In this talk, I would like to explain how to make a mathematical model of this system, dairy plant, milk powder production system, dairy plant, how to make a model. And
excuse me.
Am I audible to all?
Yes. आप इसको फुल स्क्रीन कीजिए. फुल स्क्रीन नहीं है आपकी टॉक.
अच्छा.
फुल स्क्रीन. ऊपर जो आपका यहीं पर
स्लाइड शो.
Yes.
You may go to slide show.
Yeah. You can press also F5 key.
Slide show.
Yes, this is.
Simple press F5 key.
F5P.
Yeah. F5 key. F5 key.
F5 key.
F5. Yes.
F5.
Yes. You may go from here.
Yes.
From beginning.
Yes. Is it now on full screen?
Yes. It is visible, sir, now. Full screen.
Yes. Now the topic of my talk is reliability of skim milk power production system of a dairy plant. In today's talk, I will explain how to prepare the model or the mathematical modeling of this system and then solving it. For this, to prepare this model, this talk deals with the performing modeling and availability analysis of the cereal processes in the skim milk powder production system of a dairy plant. The skim milk powder system consists of 6 subsystems. These subsystems are chiller, cream separator, pasteurizer, evaporator, drying chamber, and packaging subsystem. The subsystems are connected either in series or parallel with each other. The 2 subsystems, namely evaporator and drying chamber, are supported by standby subsystems with perfect switchover devices, and we assume that non-failure of the packaging subsystem and remaining for the subsystems are subjected to failure. 2 subsystems are assumed that they will not fail and others may fail. Now, by considering the exponential distribution of failure and repair rates of the subsystems, we prepare a mathematical formulation of the model, and we use Namic rule for these 5 subsystems, and Chapman-Kolmogorov differential equations are derived from the transition diagram. The differential equations are solved by using normalizing conditions, and we compute the availability under steady state conditions. Finally, the performance of each subsystem of the system has been analyzed for selecting the best possible maintenance strategies of the plant. The finding nowadays, due to automation in the process industries, maintenance is considered to be an integral part of the production. It is done by ensuring high availability levels. The long run availability and reliability of the system helps the management to understand the effects of change in the failure or repair rates of the component of the system. With the increase in the complexity of the system, high reliability can be obtained either by providing sufficient redundant parts or by increasing the capacity of the system. Now, I would like to now go through some literature. The available literature reveals that several approaches have been used to analyze the system performance in terms of availability and reliability. Singer in 1990, Arora and Kumar in 1997 discussed the availability analysis of steam and powder generation system of thermal power plant. Gillen and Singh in 1991, Kumar et al. In 1998, 1989, 1999, and 2007 used the Markov modeling in the analysis and evaluation of the performances of paper and urea fertilizer plants. Gupta and al. In 2008 developed the performance models and decision support system for a feed power unit of a thermal power plant. Gupta and Tiwari in 2011 presented the availability model for a thermal power plant. Khanduja et al. In 2012 presented the steady state behavior and maintenance planning of the bleaching system of paper plant. Kumar and Tiwari in 2011 discussed the mathematical modeling and performance optimization of CO2 cooling system of a fertilizer plant using genetic algorithm. Now, the system configurations are: the first subsystem A, it is chiller. The milk gets filtered after testing and chilled to about 5 degrees centigrade and stored in silos. It is single subsystem connected in series. Failure of the subsystem causes the complete failure of the system. It is provided with pump, compressor, etc. connected in series. Second subsystem is the cream separator. The fat from milk gets separated in the form of cream due to difference in density when acted upon by centrifugal force. It is single unit connected in series. Failure of this subsystem causes the complete failure of the system. It is provided with bearings, motor, gearbox connected in series. Third is pasteurizer. Pasteurizer is the process of heating milk to 72 degrees centigrade for 16 seconds and quickly cooling it to 4 degrees centigrade. Thus, by destroying the bacteria, milk becomes safe to drink. It is single subsystem connected in series. Failure of this subsystem causes the complete failure of the system. It is provided bearings and motor, etc. The fourth subsystem is evaporator. The skim milk is heated with saturated steam under low pressure to reduce the water content. It consists of two subsystems connected in parallel, one operative and other in cold standby condition. It is provided with this standby condition. Complete failure of the system will occur when both the subsystems get failed at a time. It is provided with a pump, temperature, and pressure measuring devices. The fifth is drying chamber. The concentrated skim milk is passed under pressure through a distributed nozzle. It converts in the form of fine spray of mist. When the particles of mist spray are subjected to high pressure steam, it gets converted into powder form. It consists of two subsystems connected in parallel, one operative and other in cold standby condition. Complete failure of the system will occur and both subsystems get failed at a time. It is provided with mechanical vibrator, motor, atomization devices connected in series. Now, this is the flow diagram of the skimmed milk power plant. You can see first the system is chiller, second is cream separator, third is pasteurizer, then we have evaporator. Evaporator has a standby state. Then we have drying chamber. Drying chamber is also provided with a standby state. Then is packaging. This is the transition diagram. Here you can see we have different symbols. Now this is A, B, C, D written with 0. This is the initial state of the system. It is denoted by this ellipse. Ellipse is denoted by the system is in full working state. Now this is diamond shape. Diamond shape of the system, it denotes that the system is in standby state. This is 1, this is 2nd, and this is 3rd. These 3 are when the system is in standby state. Now 3rd is this rectangular state. This state in this symbol indicates that the system is in failed state. Now you can see from here this from zero state, initial state, we get first standby state, second standby state, then is third standby state. Now from this we have simple this rectangles, this the fourth in which the first chiller is failed. Then we have fifth state. This is the fifth state. This is fifth state, and this is the sixth state. These all are failed state. Here we need the repair of the system. In 4, in 5, in 6, we need the repair of the system. Now, capital letters denote the system is in full working state. Bar over the capital letter means the subsystem are working under cold standby state. Small letters ABCD means the system is in failed. The subsystem has got failed. When there is small a means chiller has been failed. Now capital letters P0, P1, P2, P3, they denote the different states of the system. P0 means initial state. The system is in now full working state. P1, capital P1T means the system is in first standby state. P2 means second standby state. P3 means third standby state, and so on. Now we have the small letters beta i's. Beta I means it represents the constant failure rate of the subsystems. Beta 1 means the failure of A. Beta 2 means failure of B, the rate of failure of B. Beta 3 means rate of failure of C. Similarly, we have mu i's. Mu i's means repairs, constant repairs rates. mu1 means repair of A, subsystem A. And mu2 means repair of subsystem B, and so on. This PITs represent different states. Now P dash represents the derivative with respect to time. Now we need the mathematical formulation of the system. This is physical system. Now we convert this system into mathematical form. This is mathematical model. The mathematical modeling of the system is carried out to determine the long run availability of skimmed milk powder system, and Chapman-Kolmogorov differential equations are developed on the basis of Markov birth-death process, as started by Kumar and al. In 2007 and 2011. The transition diagram depicts the simulation model showing all the possible states of the skimmed milk powder system. Mathematical equations are developed by applying Markov birth-death process to each state one by one out of 19 states of the transition diagram. You can see we have 19 states. This is full working state. When chiller fails, first this chiller, then cream separator, then pasteurizer. B, C means pasteurizer. D means evaporator. E means drying chamber, and F means packaging. Now you can see here, from the initial state, we have A, chiller, B, pasteurizer, C, evaporator, D, drying chamber, and E, chiller, cream separator, pasteurizer, evaporator, drying chamber. Now from this, if the chiller fails, the chiller fails with a failure rate lambda 1. beta 1. It goes into the state 4. Now the system has been failed. We need repair of this, so we repair with this mu1 rate, and the system goes back to its first initial state. Similarly, when small b fails, b means cream separator fails, then the system goes to the fifth state. Here the chiller is working, but the cream separator is failed, the system is failed. Again, we need here the repair of the system. Then third, if evaporator is failed, the system goes into the state 6. Like this, we prepare this model. To develop this model, we use birth-death processes. So what is birth-death process? Its process refers to Markov process with, first of all, we need a discrete state space. State space means the set of spaces, set states for P0, P3, P1, P2 up to P19. These states must be enumerated with indexes. So as we have indexed them, P0 to P19. Now, the transition can occur only between neighboring states from I to I plus 1 or I to I minus 1. So lambda is the failure rate, mu is the repair rate. So with the help of this, we generate this transition equation. We develop the differential equations like this. Component-wise differential equation can be generated from here. So we developed the system of differential equations with the help of this birth-death process. First, we make this model using this birth-death process due to Markov. Here you can see QR, Ij means this is the state. The system goes from state I to state J with failure rate lambda I, repair rate mu I. It goes from I to J. J is I plus 1 or I minus 1. Yes. From here, we can see we can generate this system. This system is generated with the help of Markov birth-death process. Here are this is different. These are the different failure rates and repair rates. All the 19 states, we get this differential equation. You can see from here this. Now from this, here this is the Q0. So dQ0 by dt, it depends on outflow and inflow. Outflow with the failure like this, and inflow with the repair mu1, mu2 and mu3. So first differential equation is formed this. Here you can say derivative of first state dp naught dash. It depends on x naught means lambda 1 plus lambda 2 plus lambda 3, lambda 4 and lambda 6. These are the failure rates. Failure rate means goes out means negative. So minus x naught p naught means minus lambda 1 p naught minus lambda 2 p naught. You can see from this transition diagram this here. So this system can fail in how many ways? It can go to this, it can go to 4th, it can go to 5, it can go to 6, it can go to this standby state 1, it can go to standby state this. Now failures are lambda 1, lambda 2, lambda 3, then lambda 6, lambda 4 and lambda 6. It can fail in 1, 2, 3, 4 and 5 ways. The system can fail in 5 ways. First is lambda 1, lambda 2, lambda 3, lambda 4 and lambda 5. All these lambda. So failure rate is d p naught by dt can fail is directly proportional to lambda 1 p naught, lambda 2 p naught, lambda 3 p naught, lambda 4 p naught and lambda 6 p naught. These are the failures. In this differential equation, you will see, so we have minus lambda 1 p naught, lambda 2 p naught, lambda 3 p naught, lambda 4 p naught and lambda 6 p naught. So this part consists of failure of the state p naught. Now we come back to the original state, working state with the help of repair. Now you can see this. Now in the fourth state, this is P4. P4 is repaired with probability, repair rate lambda 1. So we write mu4, so mu1 P4. Then second is repaired P5 with mu2. So mu2 P5 is plus. Then sixth state is repaired with repair rate lambda 3. So we write mu3 P6. Then this the state P1 is repaired with rate P4. So we write P1 mu4 P1. The state second is repaired with mu6. So we write mu6 P2. So you can see here from differential equation this is mu1. This, fourth state is repaired with P1. So mu1 P4. Fifth state is repaired with mu2. So P5 mu2. Sixth state is repaired with rate mu3. So mu3 P6. Likewise mu4 P1. mu6 P2. In this way, first differential equation is generated. Here you can say this. So from here, repair, the failure depends on P0 with rates lambda 1, lambda 2, lambda 3, lambda 4, and lambda 6. So we write minus lambda 1, lambda 2, lambda 3, lambda 4, lambda 6 whole multiplied by P0. And repair is done on states P4, P5, P6, P1, and P2 with different repair rates. So in this way, the first differential equation is generated. This is Markov birth-death process, outflow and inflow. Similarly, the second differential equation is generated from here. You can say now the second differential equation is generated for the state P1. So we write dP1 by dt, derivative of state P1 with respect to time. Now we write equal to its outflows. Outflows means the failure of the system from here. Now it can fail in how many ways? It can fail in how many ways? This state can go 7, 8, 9, 10, and it can go to P0 also. This is outflows, and inflows with the help of repairs. So we write failure from the system is lambda 2. This is lambda 1, then lambda 5, lambda 3, like this. So we write generate second differential equation from here. Now third differential equation is prepared from here. dP2 derivative of P2 with respect to time t, outflows and then inflows. Fourth differential equation from here. These first three differential equations are little complex, and then we goes on to state 4. Now on state 4 there is only one outflow and there is only one inflow. That is dP4 by dt is failed with probability lambda 1. So we write dP4 by dt minus lambda 1 P4 and plus repair of P1. So mu4 mu1 P0. You can see here. This is for I equal to 4. I equal to 4 means P dash 4 plus Pj. J means 1. Okay, mu1 P4 and it is repaired with J. J means 1. Lambda 1 P0. P0 is repaired with probability this. So in this way, we prepare this model. So these differential equations are formed. This model is prepared with the use of birth and death process, and we get the system of differential equations. This 8 system of differential equations. These are not actually 8. These are 20 differential equations written with the help of these indices. Now we have one initial condition. Initially, when we start the system, you can see initially when time t is 0, all the parts of the system, all the subsystems are working in full state. This circumference system is working. So at the system, we say that probability of the system, reliability of the system is 1. The P0 is 1 and others are 0. Probability of all other states is 0 initially. Only P0 is there and other states are not existing in the initial time t equal to 0. So we have the initial condition from here. We found this initial condition. You can see this. For j equal to 1, you can say for j equal to 1, this is 1 initially and all others are 0. Now, the system of differential equation have been developed, mathematical model has been prepared, initial condition has been given. Now we have different methods to solve this system of differential equations, out of which we have used, authors have used different methods. Some of them have used Euler value matrix methods. Some have used Laplace transform methods, and nowadays we have mathematical softwares which can directly solve these differential equations. For example, we have computer algebra systems Maxima, which is open source, in which we have a direct command, Dunga-Kutta method. We can directly solve all these 20 differential equations at a time. And the reliability. Now, how we check the reliability of the system? Now we can see the system is in working state when it is either in state P0 or in P1 or in P2 or in P3. In these 4 states, the system is working. And on all other states, the system is in failed state. Now we have to keep the system either in P0 or in P1 or in P2 or in P3. So we will check what is the reliability. To check the reliability of the system, we need to know what is the probability that the system will exist either in state P0 or in P1 or in P2 or in P3. So we shall find out the probability of the system to be in state P0, P1, P2 or P3. So we calculate the reliability of the system. Reliability of the system is probability for the system to be in state P0 or in P1 or in P2 or in P3. The failure and repair rate of the evaporator λ4, μ4 and standby state are the same. Failure and repair rates of the evaporator and standby state, its standby state, both are same. Similarly, for the drying chamber, its failure rate and repair rate for both subunits, in cold by state as well as original state. For both, the failure and repair rates are same. Now we calculate this performance, and the systems are. Now we calculate the probability of the system for different values of failure and repair rates. First of all, if we take the failure rates, for example, from the company, we have obtained this data. What is the rate of failure of the subsystem and what is the rate of repair of subsystem? From there, we have got this data, and we have varied this data for different values. For example, λ1, failure of the chiller, failure rate of the chiller, we have variated it in this way, whereas all other failure rate and repair rates are kept same. With this, we have found the value of the reliability using the above differential equations and the reliability equation with the help of Maxima, using directly the command Runge-Kutta method, which is present in case Maxima. We have used this table. These tables are different failure and repair rates. And this is the program which we have used in Maxima. You can see. First we have calculated using Runge-Kutta method the values of P0, P1, P2, P3 and up to P19. Using initial condition, P0 is 1 initially and all others are 0. Then we have varied with time from 0 to 360 in steps of 0.005. We have got this point at different values of T.
Hello.
Hello.
Ji sir, please conclude it. You have
okay.
completed.
Yes. I concluded. They use this program, and the system is now reliability we have observed that reliability varies from 0.02 to 0.0193 while increase in repair rates of this. And these are the references.
Okay.
Thank you.
Okay. Thanks, Professor Tarun Kumar Garg. I now call to Professor Khalil Ahmed. Please unmute him. Dr. Sundar Singh ji. Khalil Ahmed. Hello. Hello. Hello, Dr. Sundar Singh ji. Hello.
Hello, can you hear me, sir?
Yes.
Hello.
हाँ,
Yes, Dr.
unmute
Khalil Ahmed.
जी.
Dr. Khalil Ahmed, unmute yourself.
Hello.
Dr. Khalil Ahmed, can you hear me? Unmute yourself. Dr.
Professor
Avnishan.
Khalil Ahmed.
Dr. Avnishan. One second, sir.
जी. Sir, unmute yourself.
Okay.
Yes, sir. Now our next speaker, Professor Khalil Ahmed, retired from Jamia Millia Islamia. He has been the head of the Department of Mathematics and Dean, Faculty of Natural Sciences, Jamia Millia Islamia, New Delhi. Currently, he is working with Department of Mathematics, Al-Falah University, Faridabad. His field of specialization is functional analysis and applicable mathematics. His precise topics of research, theory of basis and decomposition of Banach spaces, vast approximations, variational inequality, complementary problems, and wavelet analysis and applications. He has been guided 14 research scholars. I am one of them. And he had, hello,
Hello.
yes, he is reviewer of research papers sent by Mathematical Review, American Mathematical Society, and referee in various research papers published in various journals from India and abroad. He authors 49 research papers in various national and international journals. He has been authored 16 books published by national and international publishers. Now I request to my teacher, Professor Khalil Ahmed, please deliver his lecture on application of wavelets in signal and image processing. Now I share the screen.
Okay.
Please.
Thank you.
Yes,
Let
I
us
will share
start.
the screen.
Yes. Please.
I will share 1 minute.
Yes.
Yes, I think it is. Hello?
Okay. Okay. Okay.
Yes, sir.
Let me start.
Yes, sir.
First of all, I thank the organizers of the conference, in particular Dr. Anil Kumar and Dr. Kesh Kumar. Today's lecture, I decided to speak on applications of wavelets in signal and image processing. Actually, this is new area, which is from electrical engineering, and we are interested to apply mathematics in signal and image processing. Actually, we have been working in this field for the last 5 years, and the work started in collaboration with Dr. Tarun Kumar Garg and Dr. Rakesh Kumar, and had done a lot of work in wavelet and wavelet packets. And after that, we decided to apply wavelets in signal and image processing. Up to some extent, we are able and have got success in applications. So I will point out here some applications in signal image processing. So first of all, I would like to discuss about the wavelet, and there is another general concept will be a wavelet packets. In fact, we consider the set of integer set of real R, and we define the inner product, and that is like in the form of integral. And yes, next please. Yes, the very important concept of multi-resolution analysis. In multi-resolution analysis, there are certain conditions which are satisfied, should be satisfied for the space L2R. And these are Lebesgue integrable functions. And here is what condition. The condition is that condition 5, f belongs to Vj if and only if f2 x2 minus j belongs to j for all belonging to Z. The function phi mentioned 4 is called a scaling function, and this function is also known as Father wavelet. And actually, here we are obtaining orthonormal wavelet. If orthonormal wavelet is obtained for this function phi, then this will be known as scaling function as well as Father wavelet. Then with the help of Father wavelet and by using the fundamental or main theorem of functional analysis, and that is projection theorem. By using it, with the help of that theorem, we are defining another function in regard to the function phi. That function is denoted as and that is known as mother wavelet. Then the help of father and mother wavelet, there are so many wavelets generated, and in fact, wavelet that is created with the help of father wavelet as well as mother wavelet. And that's also very important. Sometimes in applications, wavelets are useful and we are getting good results, and sometimes it is advisable instead of using wavelets, but we have to apply wavelet packets in order to get better results. So I will take some examples to show how we are working in wavelets, application of wavelets. Next, please. Yes, next, please. Yes, next. Yes, there are two types of signals, and these are very, very important in engineering. Stationary signal and non-stationary signal. Stationary signal are handled by using Fourier transform. So electrical engineers are very, they know the application of Fourier wavelet in handling the stationary signal. And example, in mathematics, you can see the signal of sine function as a cosine function. That is to handle these signals, it is simply we have to apply Fourier transform. Now the problem arises when the signal is not stationary, that is non-stationary. In that case, we can Fourier transform, we have to go further. Actually, when there is a negative something, then we are getting something positive. So when Fourier transform is failed, then people started to find out other ways to apply and to find out the solution of the problem. And they have generated the wavelet transform. And wavelet transform is very much useful in handling the non-stationary signal. So here, the signal is transferred over a communication channel perturbed in a variety of ways, including channel distortion, fading, and the ingestion of background noise. One of the objectives at the receiver is to compensate for these disturbances. In each case, processing of signal is required. Sometimes you are standing in a market and you are calling to some person by your phone, then background noise will be there. So there is a problem how we can reduce that. It is a still open problem. No solution is obtained. So now people are working, and also this is here is the role of mathematicians to solve this problem. Yes, next please. Yes, next. Yes, first of all, we have considered, no, the first one, the first signal. Yes, go back. Yes, go back. Yes, okay. And this signal we considered as ECG signal. And ECG signal is very, very important in the study of uh, in detecting the heart problem. So first of all, we have considered and we have taken this from it, and we have added noise and and then we have started to denoise. And denoise is not very simple, but it's very difficult, and we have to apply the wavelets. For the simulation and results, actually I will discuss for simulation of the proposed method an ECG signal we have considered, which is shown in figure A. The sampling frequency is 16 kHz and 4,000 samples of the original of the signal are used. White Gaussian noise is added to the original ECG signal to introduce distortions. This noisy signal is shown in figure B is used as the test signal for the simulation of the proposed method. Dobeshi's DB3 wavelet is used to decompose the signal up to 4 levels. This simulation is done using MATLAB 7.0. Estimated signal from the noisy ECG signal using proposed method is shown in figure C. From the figure, it is clear that the noise has been reduced. Denoising of ECG signal is performed using all the 4 threshold value estimators to compare their performance. Both hard and soft thresholding are used to evaluate the performance of the method. Mean square error is computed for various values of signal to noise ratio, that is also known as SNR, and we can show the results in tables. Actually, what we did here, we have considered the signal, then we have added the white Gaussian noise, and then we are interested to denoise. It is not so simple. Just like if we add water in milk, we cannot separate. It is not so simple, very difficult. So the same problem is also here. Add the Gaussian noise, white Gaussian noise. It is difficult denoise. By using lab and wavelet tools, and we are doing our own coding. Actually, this work is being done in collaboration with my 2 research scholars, Dr. Pankaj Sharma and Dr. Kashif Khan. They are very expert in MATLAB as well as in coding. And then if we compare the first one and the last one, that is the original and the signal which we obtained after denoising, there is minor difference. That is, we are getting approximate value, not the exact value. Then we have considered another signal that is generated by ourselves. Just if we speak apple, signal will be generated. So the same thing we have done in this signal also. We have added white Gaussian noise, and then we have tried to denoise. And if we compare the first one and the last one, third one, there is a little difference. That is, we are getting the approximate value, not the exact value. After not only these are 2 signals, we can say a number of signals. If somebody is interested, I will show in our references. Anybody interested, you can share. Then we decided, actually, these signals are one-dimensional. So we decided to work on 2-dimensional signals, that is images. And to work in images, that was not very simple, but this becomes very difficult. Anyway, we have succeeded. And the work which I am presenting here, just glimpse of our work. And this is published in International Journal of Waves. And actually, this is published by this is AI journal, and this work was appreciated by the publisher itself of the journal. So here what we have
Yes.
of a small, we can reach next one. Yes. Next slide, please. Yes. So first one is original signal, and the second one, that's the denoised image. Compare the two, there's very little difference that get an approximate value. So by using WCs, we have WCs 3, we have been able to denoise image also. But that's not so simple, but it's very difficult. Anyway, we have succeeded, and our work was appreciated very much. Yes, next, please. Yes, actually, this is a view Hawa Mahal object, and this one from the internet. The same thing we have also done in this picture, that we added the white Gaussian noise, and we have denoised, and deposition we done up to level, and like original image, the first one, and the denoised image, the second one, and compare the two in a big shape, then there will be little difference that you get in the approximate. After that, we decided that actually here we used weights. Then we decided that we should also do some other problem by using wavelet packet. So the figure is also of a child, and we have decomposed for level after adding white noise, and we have got the result. First one is the original image, and second one is the denoised image. And also we have shown that the results obtained here are better than the results were obtained by using wavelet. Yes, next, please. Yes, this figure I have taken from the internet. Earlier, that was taken by ourselves from our camera. And the same thing we have done in this picture also, and we got the results, and results are very much useful, but is also pleased. We're coming to the references. Actually, this is the book which have written as a textbook of people want to start the course on wavelets at universities. So the first one is used as a textbook, and the second, that is paper with Pankaj Sharma, Ashif Khan, and myself. This was published in International Wavelet Multi-Resolution and Information Processing. And third, that is on wavelet pack. This was
Yes.
is published with Alpha itself, and result is stated, and this is cited in different keys of the world. And fourth one, motivated by this work as we have for the last 20 years, we are able to write it with Dr. Abdullah with packets and their statistical applications. And this book is published by Springer Nature. And not only here, I have shown only 4 results. There are a number of results which are given in this book, but interested, you can see. And also, if you want for your personal purpose, then I can send you this book. There are other applications of wavelet, various wavelet packets. Just we have discussed in signal and image processing. There is a application in string theory, turbulence, geophysics, statistics, economic finance. Actually, we know the stock exchange, there are always differences in the morning as in the evening. There is sudden change. So signal is generated as non-stationary signal. Wavelets are used. If somebody knows wavelets, he can do good business. Then wavelets are also used in quality control, different equations, and people who are working using wavelets in differentiations. Neural networks, this is area where wavelets are used. In astrophysics, there is also application of wavelets, quantum mechanics, chemistry, and this area fracture mechanics. In fracture, nobody can guarantee that the fracture will be smooth. So there will be edges, and they have to apply wavelets. And there is a group working in Jamia Islamia as well as IIT Roorkee. They have done a lot of work using the problem that fracture is smooth, but that was not true. Now they have decided to apply wavelets.
Yes, sir.
Yes. Thank you.
Please. Okay. Thank you, sir, for nice lecture. And I think the audience will be fruitful. And now I request to Dr. Dilip Kumar for vote of thanks.
Oh.
Dr. Dilip Kumar.
Am I audible, sir?
Yes.
Thank you, sir. First and foremost, I express my thanks with a deep sense of gratitude to Almighty to make this program a success. Now I convey thanks to eminent speaker, Professor Birpal Singh sir from CCS University, Meerut, for such an exceptional and elegant talk. Thank you, sir. Now I propose vote of thanks to esteemed speaker, Dr. Tarun Kumar sir, from Girls Satyavati College, Delhi, for such a thought-provoking talk. Thank you, sir. Now I offer thanks to legendary speaker, Professor Khalil Ahmed sir from Jamia Millia Islamia, New Delhi, for such an outstanding and remarkable talk. Thank you, sir. Due to some unavoidable conditions, distinguished speaker, Dr. Rahul Singhal sir from Central Connecticut State University, New Britain, was not able to join us, but I extend thanks for accepting our invitation. Now I give thanks to Chairman Dr. B.B. Singh sir, Principal Hindu College, for constant support and encouragement. Thanks, sir. Now I express thanks to Deputy Chairman Dr. Mukul Kishore sir, Head Department of Physics, Dr. Sanjeev Rajan sir, Head Department of Mathematics, for suggestions and guidance whenever required. As we all know, audience is a backbone of any program. Hence, a big and special thanks goes to entire audience. I thanks to all members of organizing team for planning and execution of this program. Finally, I thank to technical team, print media, electronic media, and everyone who is directly or indirectly supported this program. Thanks again to all of you. Hope you all enjoyed and will support us likewise in future also. Thanks a lot to all. Thank you.
Okay, thank you, Dr. Dilip Kumarji. Now we have two parallel sessions, one for physical sciences and the second for mathematical sciences. So some of the participants who are physics and other departments, they will join the Google Meet by the given link, and the other who are from mathematical sciences background and mathematics, they will join the same after leaving this. Okay, thank you. So please gather within 2 or 3 minutes in the two different platforms. Thank you. Dr. Ravish Kumar ji. Dr. Ravish Kumar Yadav.
Yes, sir, is there.
So unmute
Please,
yourself.
sir, please unmute yourself.
Hello.
Unmute yourself.
Yes,
Can
yes,
you hear
not-
me?
Yes,
Yes,
sir.
yes, yes. Now,
Hello.
yes, yes.
Yes, sir, you are audible.
Let's start this session. Or we must take
Please
some-
wait for 2 minutes. Please, first time you please announce the name of the presentators, I think.
There are. I think we
you
must
have the link?
start. We must. Hello.
Yes, yes.
First presenter is Dr. Nitin P. Gaikwad, 40, M40.
Please name the other participants also in mathematics.
Sir, I am here. I am in. Dr.
Yes,
Gaikwad.
yes, you can proceed.
Sir, can I continue?
Yes, you can continue.
Okay, sir, I share my screen.
Yes, you are already on the screen.
Very good afternoon to sir. Can I start?
Yeah.
Hello.
Start.
Hello.
Please start.
Yeah. Yes, sir. Very good afternoon to one and all. All the dignitaries, chairperson of this session. I, Dr. Nitin P. Gaikwad, presenting my research paper, LRS BNG type string fluid cosmological model in Rosen's gravity. I am from Department of Mathematics, Dharampet MP Memorial Science College, Nagpur, Maharashtra, India. Here I have presented my research paper. The abstract of this paper, in this paper, I have presented the solution of LRS BNG type 1 space-time string viscous fluid by solving the field equations of Rosen's gravity. Rosen's biometric theory of gravitation, it is differ from theory of gravitation because it is free from singularity. This theory of biometric theory of gravitation is done by Nathan Rosen in 1973-74. He created this equation which is given in capital 1, Nij minus 1 by 2 capital N delta Ij is equal to minus 8 pi k Tij. Here, given that n is equal to small gij nij, which is a Rosen square scalar, small k is equal to under root g by gamma, where g is the determinant of gij and gamma is the determinant of gamma ij. Now, here we have to consider the LRS BNG type 1 matrix, which is given in equation 3.1. The matrix is dA square is equal to minus dt square plus a square dx square plus b square into dy square plus dz square, where a and b are the functions of cosmic time t alone. Now we have to consider the flat matrix corresponding to this matrix equation 1 given in equation 3.2. Now here we assume that the energy momentum tensor containing a bulk viscous fluid and one-dimensional string with electromagnetic field, which is given in equation 3.3, and where the physical parameters are given there: p, rho, lambda, xi of t, theta. Now we have to assume that a particle attached with the string and the energy density rho p of the particles is given by rho p is equal to rho minus lambda, where now and again we have to consider Eij, which is a part of energy momentum tensor corresponding to the electromagnetic field, and it is defined in equation 3.6. Using the equation 3.6, we will get this four equations: E11, E22, E33, and E44. And using this all these values of energy momentum tensor, we will get the values of energy momentum tensor T11, T22, T33, and T44. And now we have to find out the log conservation of energy momentum tensor, which is given as Tij, which is a covariant differentiation with respect to J, is equal to 0, which is given in equation 3.11. Now, from equation 3.12 to 3.14 are the Rosen's field equation, which is calculated by using the Rosen's biometric theory of gravitation. Here, given that A dot is the first order differentiation with respect to T, double dot means second order differentiation with respect to T. Now, we have to denote it here. Alpha is equal to A dot by A and beta is equal to B dot by B. And now the conservation equation 3.11 and the field equation 3.12 and 3.13 can be rewritten as, means we have to substitute the values of alpha and beta in that equations. We will get this equation. Now we study the metric and field equation. Here we get 4 equations, which is given 3.15, 3.16, 3.17 and 3.18. Now and 7 unknown quantities. So we have to assume three conditions for this. To solve this metric, we have to assume 3 conditions. The first condition, we have to assume that the relation between alpha and beta, which is alpha is equal to k beta, where k is constant, which is greater than 0. Second condition is between energy density and string tensor density, which is rho is equal to gamma lambda, where gamma is arbitrary constant. And the third condition is barotropic cosmological fluid, which is P is equal to epsilon rho, where that epsilon is in between 0 to 1. Now, using these 3 conditions, we have to find out, we have to solve this 4 differential equation. We will get equation 3.20, which is given that 1 by L square capital into capital M beta dot plus capital N beta square, which is equal to 0, where 16 pi exponential of alpha plus 2 beta integral of alpha plus 2 beta dt is equal to L square, and M and N is the constant one. Now we have to solve equation 3, M beta dot plus N beta square. We will get the scalar factor A and B, which is given in equation 3.26 and 3.27, where a small a1 and small b1 are the constant of integration. Now choosing small x is equal to capital X, small y is equal to capital Y, small z is equal to capital Z, and small a1 is equal to b1 is equal to 1, the required matrix can be converted into the matrix given in 3.28, which is the string fluid bulk viscous cosmological water with magnetic field in biometric theory of gravitation. Now we have to discuss the volume V. V is equal to AB square and is given by V is equal to T to the power K plus 2 M by N and exponential of K plus 2 BT. This expression suggested that the model has volumetric exponential expansion. Now, thus physical expansion, now here the physical parameters are given of the model, which is given in 3.29 to 3.30, 3.31, 3.32, 3.33, 3.34, 3.35, 3.36, 3.37, 3.38. These are the physical parameters which is calculated by me. In the absence of bulk viscosity, which means xi is equal to 0, we have to consider this condition. We will get delta is equal to E44, which is in equation 3.39, and all the physical and relation between all the physical parameters are given in 3.40, and the Q is equal to -1 in 3.41. Now the conclusion. We have investigated magnetic field in the presence and in the absence of bulk viscosity in biometric theory of gravitation. It is seen that our model has volumetric expansion. All the parameters P, rho P, lambda, theta, and sigma of the model are governed by the factor beta, and only if beta is 0, all the physical parameter vanishes, which shows vacuum universe with expansion without shear, but it has a magnitude field and accelerating expansion for beta is equal to 0. It is noticed that our model is exponential expanding with accelerating expansion for n by m is less than 0, which supports the observation which is given by Permeter in 1997-98, Knob et al. 2003, Tegmark 2004, and Spurger et al. 2003-2006. Thank you.
Thank you, Dr. Nitin, for your nice presentation. Now, next participant is Dr. Lingraj Angadi. Next participant is Dr. Lingraj Angadi. Can you hear Dr. Lingraj?
Unmute yourself.
Oh, yes, Dr. Lingraj.
Dr. Lingraj, please unmute yourself first.
I think he is not present. Hello. I think
Dr. Madan Lal.
Lingraj is present. Yeah.
Dr. Madan Lal. Hello.
Dr. Madan Lal is present. Yes.
Continue, please.
Please unmute me.
Continue, please. Share.
Am I audible?
Yeah.
Yeah. Okay. A warm good afternoon to all of you. Myself, Dr. Madan Lal, Head Department of Applied Mathematics, Faculty of Engineering, MGP Rohilkhand University, Bareilly. Before presenting my research paper, I want to express my sincere thanks to the organizers of this conference, especially Dr. Rakesh Kumar and Dr. Anil Kumar sir, due to which it is possible to me to present the paper in this conference. As all of you are either in your home or at your office. While we have to gathering in Hindu College Muradabad, the reason behind this is the dangerous coronavirus. So the topic of my today presentation is a study on the spread of coronavirus. I have divided my study in the following sections. Firstly, I will present abstract, then introduction, then statistical modeling, then research data, extrapolated graph, research design, result, discussion, suggestive measures and references. Yes, I am sharing this. Yes, please allow me to share the screen. Yes, please allow me to share the screen. Yes, am I audible? Yes.
Yeah.
Firstly,
Please
I want to
share your screen. You are able to share your screen.
Yes. Thank you. In the present study, I have collected the data from the source Ministry of Electronics and Information Technology. Actually, I have used Excel trend function to predict the extrapolated graph of active cases, infected population, and recovered cases. We have used value ratio, which will become more than 80% on 26th of July. And we have discussed that the infected population will be flattened after the last week of July or after the first week of August. As you know, a deadly virus which infected millions of lives worldwide came into existence in the world in the December 2019 in the Wuhan city of China. Over the world, this unknown virus infected a large number of people. The disease caused by novel novel coronavirus was named COVID-19 by World Health Organization. Due to its unique behavior of rapidly spreading from person to person, coronavirus was declared as a pandemic by WHO. Many of the authors have completed his work in their own country. I have studied for India. It is well known that everyone is looking measures to predict when the curves of active cases of COVID-19 will be flattened over time. We have used the extrapolation method to predict the behavior of variable based on previous available data. This can be achieved by fitting a function to a curve and then using it to calculate the values of data out the domain. In this article, an attempt is made to predict and analyze the COVID-19 cases in India using polynomial extrapolation. Moreover, Valley ratio is also predicted using extrapolation. In the statistical modeling, Valley model is a chain binomial type model which assumes short period of high inflections and almost constant incubation period. Let us assume that the susceptible population is alpha and infected population is beta. Then in time dt, the chance of a new inflection will be x alpha beta dt, and by beta dt shall be the chance of its removal, where x and y denotes the inflections of removal rates respectively. In the long time, as t tends to infinity, the ultimate distribution of the pandemic is expected. What the infection rate x and removal rate y cannot be estimated separately. Although the removal rate can be calculated as rho is equal to x upon y. And we have used the data from Ministry of Government. This data is taken from 18 March and after 5 days of interval to 26th of June. From this data, we have drawn a graph between infected population, recovered patients, deaths, and active cases.
Please conclude, sir.
From this graph, we can say that as the statistical suggests, total infections rapidly over the month, but preventive measures taken have also increased the number of recovered patients very quickly, keeping the active cases less. On 18 March 2020, the Valley ratio was 6.62, but on the 26th June, Valley ratio will become 58.24 in India. Now I hope that the Valley ratio will approximately over 80% on the 26th July 2020 in India. And from which we can discuss that as everything has its pros and cons, pandemic has too. The pandemic has brought a number of positive as well as negative changes in the country. The coronavirus pandemic has led to fall of economy and employment of a large number of laborers, closing down the factories, business, etc., etc. People who run their family by earning daily suffered the most. The habit of common man for their work had negative impact. The people started feeling depressed by staying at home. Many pupils tested death by suicide during the period of lockdown. People also suffered from treatment of general disease due to the coronavirus. Although the pandemic brought negative changes, but it has saved many lives too. Every minute a road accident happens in India. This accounts for approximately 5 lakh cases of road accident in India each year, out of which approximately 1.5 lakhs lost their lives. During the period of 5 months of pandemic in India, due to preventive measures of lockdown, the number of road accidents were only around 1,750, out of which approximately 850 people lost their life. Thus, the
please.
pandemic brought
Sir,
a
please.
positive change in India. Yes,
Madam
I
Lal.
can.
Okay.
Yes, I am going to conclude. Thus, the pandemic brought a positive change in India by reducing the road accident from lakhs to few thousands. And due to which I give the following suggested measures. Some of the taken from Ministry of Health and Family Welfare, and in which we can say that proper use of sanitation, mainly for children sanitizers, it contains alcohol which is flammable as well as poisonous. Thus, sanitizers should be kept away from flames and from the reach of the children. The money in the form of coins and notes, if comes in contact with the infected person, it can infect the other persons too. And we have used the following papers and authors of the papers. So these are the references. And
Okay, thank you.
as I am not COVID-19 expert, so the research on mathematical model can prevent the coronavirus outbreak in India. The above study up to 26 June. Thus, depending on human trends and the changing behavior of the coronavirus, there may be different trends to data as expected. Thank you very much.
Okay, thank you.
Yeah.
Dr.
Any
Ravish Kumar.
question,
Thank you,
please?
Dr. Madalal.
Yes.
Any question?
Any question, please?
No, I
Any
think there is
question
no
from the
question.
participant?
No participants are muted, so I think that if anyone had questions, then he will ask directly through the WhatsApp groups.
Yes.
Now,
So, yes, sir.
we go to next participant.
डॉक्टर के रघुनाथ
के या जो बीच में रह गया था उसको ले लें,
बाद में देख लेंगे. डॉक्टर के रघुनाथ.
ठीक ठीक ठीक, ओके.
And you have 6 minutes only. Every participant have 6 minutes, so please conclude in 6 minutes.
Keep in mind time frame.
Dr. K. Raghunath, are you here? Dr. K. Raghunath, raise your hand. Dr. K. Raghunath is not here. So please call the first if he is here. Lingram M. Angadi. Lingaraj M. Angadi. He is not also there. Hello, Ravish ji. Please call the next participant if he is here.
Next is Amit Chandrakar. Amit Chandrasekhar.
अमित चंद्रशेखर और ये भी तो हारिस आलम जुवैरी. हारिस आलम जुवैरी.
यस,
हारिस आलम जुवैरी भी तो है कोई.
अमित चंद्रशेखर है.
यस यस, ही इज देयर.
या हरीश आलम जुवैर ले लीजिए. यस.
Unmute yourself. Hello.
Hello.
Yes.
Haris Alam Juveri is my student and I had present the paper.
Okay, okay.
Okay.
Who is next?
हरीश आलम जुवैर.
नहीं, दूसरा नेक्स्ट है वो है नहीं.
नहीं,
आप उसको देखिए जो भी हैं आपके इसमें.
डॉक्टर अरविंद वी देसी.
डॉक्टर अरविंद विदेशी.
डॉक्टर अरविंद बी देसी.
हेलो.
इज प्रेजेंट.
डॉक्टर अरविंद विदेशी.
Nice presentation. Statistics is very informative. Thank you, sir.
किनका
सी विमला चैट में देखेंगे आप.
अरविंद विदेशी, unmute yourself.
हाँ, इस मेरे थ्रू पर मैंने करा भी इससे
सर बोल नेक्स्ट चले. डॉक्टर अरविंद विदेशी नहीं है.
हैं.
यस.
लिख दें इनको।
इनकी स्क्रीन शेयर बंद करवाइए इनसे। हेलो,
कैसे लिखा जाएगा?
इसी में ही सब कर देंगे तो सर, लेकिन सबको जाता है वो।
हेलो, म्यूट। अवनीश जी।
यस।
अवनीश
हाँ
जी,
जी, हाँ जी सर, जी
ये
जी
म्यूट
बताइए
म्यूट
बताइए।
करिए। हेमल गंगवार जी को म्यूट कीजिए, मनहरलाल जी को,
हेलो।
और नेक्स्ट जो अरविंद जी देसी हैं उनको करिए आप।
अरविंद विदेशी को
नहीं,
लाइन
मैं
पे
को
लीजिए।
होस्ट बना दिया है, लेकिन वो जो है अपने आप को शायद हमें लगता है उनका वॉइस नहीं आ रहा है यहाँ पे।
अच्छा
वो अनम्यूट हो गए हैं, लेकिन वो नेटवर्क इशू है हमें लग रहा है।
अच्छा अच्छा। So we call, I think, next participant.
नेक्स्ट पार्टिसिपेंट इज गोरमे गोडागी। गोरमे गोडागी।
Goramma A. Godavi. See here.
नेक्स्ट पार्टिसिपेंट इज गोरमे गोडोगागी।
Goramma है, Goramma. Goramma A. Godavi. Please.
यस।
नहीं है। Hello. I think she is not available. Any participant who is available? N.K. Inagi.
नेक्स्ट डॉक्टर लक्ष्मी नारायण कुंडेरू।
Dr. Lakshmi
डॉक्टर
Narayan
लक्ष्मी
Kundaru.
नारायण कुंडेरू अवेलेबल इज।
Sir, Amit Dabole, present
Yes.
here.
Yes, yes, yes.
Yes.
Okay. Please start. No, this is Arvind Videsi. Please, Arvind Videsi. Hello.
Please start.
Sir, Amit Dabole, 33 number.
Hello. What is your number?
33.
33. It means you will in physics.
In mathematics, sir.
Mathematics.
33 male.
45
Amit Chandrasekhar Dabole.
Yes, yes. 45 पे है. Okay. You have not seen new list. So please start. ये अरविंद विदेशी का स्क्रीन नहीं, स्क्रीन तो ये अरविंद विदेशी जी की आ रही है। हेलो अमित जी।
Can you hear, Dr.
अमित जी,
Arvind?
वो अवनीश जी।
हाँ यस
सर, जी जी बताइए।
अरे इसमें स्क्रीन आ रही थी, स्क्रीन अरविंद विदेशी जी की आ रही है और आवाज आ रही है उनकी दूसरे वालों की।
चलिए मैं अभी देखता हूँ, मैं देख रहा हूँ अभी।
इसको देखो, सही करो जरा। ये जो बोल रहे थे उनसे शुरू करा दीजिए।
हाँ,
अमित चंद्रशेखर। यस
अमित जी, प्लीज स्टार्ट योर प्रेजेंटेशन। अमित।
How should I share my screen? Please allow, sir. Sharing my screen.
Screen is from another person.
You are able to share your screen, please. Amit, Mr. Amit,
Yes, sir.
share your screen.
Yes, sir. How should share? Yes, sir.
Yeah, your screen is visible. Please continue.
Yes, sir.
Please continue.
Yes, sir. Good afternoon, one and all. Thank you for giving me this opportunity to present my paper in your conference. The paper topic is zero divisor graph of the lattices Ln, Ln12 and Ln dash. So here I have considered three different type of lattices, and regarding that I have represented a zero divisor graph.
Yeah.
Sir, my voice is audible?
Yeah.
Yes. Okay. Thank you. The highlights of this paper are abstract. Some points we have discussed in this paper, that is order of zero divisor graph, independent set, diameter, clique, and dominating set of the zero divisor graph. So these are the points related with the lattice theory and the graph theory. And in the last, the references we have. Now, some properties of zero divisor graph, this we have discussed. In fact, these three different lattices are this one. First is the lattice with Ln, which is a square free integer lattice. Another lattice Ln12, that is nothing but one prime factor having the power which is a square. And the third Ln dash is nothing but a prime factor having nth power with positive integers. So these three different lattices we considered. And in that, we denoted it by gamma Ln, gamma Ln12 and gamma Ln dash. These are the notations we have used. The actual definition of zero divisor is if A mid B is equals to 0 in the lattice, then these two elements are adjacent in the zero divisor graph, where A is not equal to 0 and B is not equal to 0. Now in the next slide, the first point is order of the graph. Order of the graph, it means the number of vertices in the given graph. So here we consider zero divisor graph. In that, the number of vertices, this we can calculate by using the formula of binomial expansion, summation of r equals to 1 to k minus 1 kcr. So for how this screen is new. So somebody's screen get occurred in my presentation.
स्क्रीन उल्टी कैसे आ रही है अरविंद विदेशी की?
अविनाश जी, अवनीश जी,
जरा देख रहे हैं
Yes, sir.
अरविंद
इसे
विदेशी की आ रही
स्क्रीन
है?
कैसे हो रही है?
Sir, automatically it go on. I doesn't know how it. Yes, sir. Now got it.
Technical problem.
Okay.
Yes.
You may continue, Amit.
Yes, sir. So this formula, now this lattice Ln we have considered here. In that, the number of vertices in this lattice, there are 16 vertices. And if we draw the zero divisor graph of this lattice, then in that there are 14 elements. And these 14 elements for any type of Ln lattices, this we can find by using the formula in the theorem 1. So this we have discussed by using the graph of lattice. Now the same lattice we have considered with the Ln12 lattice. In that, again we got here the new formula to find out the order of the given graph of the lattice Ln12. Now the next point is independent set of a graph. So if we consider a lattice Ln or Ln12, and if we draw the zero divisor graph of that lattices, then in that the number of pair of non-adjacent vertices is nothing but our independent set. So here we got one formula in the zero divisor graph, the number of largest or the maximal independent sets we can find, and this cardinality can be defined by using the binomial formula. Now here we consider one lattice L of 210. In that lattice, the prime factors are 2, 3, 5, 7, and in that lattice, the number of vertices we have considered, these are nothing but 3, 6, 15, 21, 30, 42, 0. These vertices in the given zero divisor graph, they are not adjacent to each other. So these vertices I highlighted with the dark circles, where any two blue vertices are not adjacent. It means they are nothing but the independent set of zero divisor graph. Similarly, we have considered the another lattice Ln12, and in that again we find here the independent set of gamma Ln12. This formula we can define, and in that we consider one example L of 42012. It means one prime factor, that is 2, is repeated twice, and 2's power is 2, and other factors our power is 1. And in that list, this is the set 2, 4, 6, 10 up to 140. This is nothing but the independent set, and this independent set is the largest in that zero divisor graph. So this is the zero divisor graph of that lattice L42012. Now, if you'll see here in that graph, any two blue vertices are not adjacent to each other. They are distinct. They are not adjacent by any edge. For example, suppose I consider here 2 and 10. So these two are not adjacent. They don't have any edge. So such vertices we have considered in the independent set. The next point we have discussed here, the diameter of that zero divisor graph. Diameter is nothing but the greatest distance between any two pair of vertices. In that, three different cases we observed here. The first case is if n is equals to prime factors p1, p2, then the diameter is 1. If n equals to p1, p2, and its power is nth power positive integer, if it is greater than 1, then the diameter is 2. And if we have n is equals to ln dash type of lattice, with prime factors having the nth power positive integers, then in that case the diameter is 3. So these three different cases we got here for the diameter under the zero divisor graph of the lattices. The next point is clique of zero divisor graph. It is nothing but the number of pairwise adjacent vertices in that. Now we got here one result, that is a remarkable result for any type of ln dash lattice. In that, the clique of that size is always k. So here, suppose L of 210 we consider, and its zero divisor if we draw, then there are four vertices 2, 3, 5, 7, which is the clique of that graph. What is the clique actually? By graph we can understood. Each vertices highlighted with the blue are adjacent to each other, and this is the maximum size of that graph. So the clique size is 2, 3, 5, 7, where these four vertices are adjacent to each other. The next heading, that is dominating set of a zero divisor graph. Now in that, the dominating set is nothing but the set in which the vertices for that other vertices are adjacent. So minimum dominating set for the gamma ln dash lattice, it is p1 to pk. We consider here L of 42012 lattice, and in that there are p1 to pk. These are our dominating set, and for this lattice the dominating set, it is p1, p2, p3, p4, and the order it is 4. So 2, 3, 5, these are nothing but the dominating set of the given graph. So these are the points, different points we have discussed under the zero divisor graph of the three different lattices. Now these are the references. This we have used here for the conclusion of this paper. Thank you. Thank you, Vanya.
Thanks.
Thank you.
So any question? Dr. Ravi Kumar ji?
Any question from the participant?
Now, next participants.
Dr. Arun B. Desi को बुला लो.
हाँ, call. Dr. Arun B. Desi. Dr. Arun B. Desi. Hello. Please. Arun B. Desi.
Not available. He is not available.
उस समय उनकी कैसे स्क्रीन आ रही थी?
वो अबे हमें लगता है वो डिस्कनेक्ट हो गए हैं अभी.
अच्छा अच्छा. So next, Dr. Gauramma A. Godagi. Dr. Gauramma A. Godagi. है नहीं है? No. Lakshmi Narayan Konduru. Lakshmi Narayan Kundaru. Yes, sir.
Thank you, sir.
Yes, yes.
Yes. Yeah, good morning, all.
Okay.
And myself, Dr. K. Lakshmi Narayan. I am working for Vijay Jyoti Institute of Technology, Hyderabad. And today I am going to talk about the concept of a mathematical study of enterohepatic circulation of drugs with time delay in two-compartment model. First of all, I would like to thank the organizers for giving this opportunity. And my presentation is like first I'll talk about abstract, then introduction, then formulation, then the mathematical solution, analytical solution, then supported by the numerical simulation. So in this model, we considered a two-compartmented model, and it explains the pharmacokinetics of a drug with oral administration focused on enterohepatic circulation with time delay. And we consider the delay between the circulation between the second compartment and the first compartment. And here we consider two compartments, and the first compartment is the liver. So this is the first compartment, and in the first compartment usually we are taking it is considered as a central compartment, and in our body the organs which are highly flooded with the blood are considered as the central compartments, and like liver, lungs, and heart, all these are considered as a central compartment. And we consider a central compartment as well as a peripheral compartment. And here we consider so oral drug administration, and here a drug is administered and it comes to the intestines, and from this intestines, so it moves through this portal vein, it goes to the central compartment, and in the central compartment, so it mixed with the bile acids and it comes to the gallbladder, and then again it comes to the intestine. And we are considering the delay in this process. So when we administered a drug of an amount D, and initially, and this delta T is the Dirac delta function or unit impulse function, and when this is administered, it comes to the first compartment, and this second compartment, and the second compartment has two excretions. So one is going out, K20, and another one is going to the central compartment. Central compartment is denoted by this X1T, and after entering into the central compartment, so it mixed with the bile acids and coming to the gallbladder, and again it comes to the second compartment again, and the central compartment also has an excretion which goes out. Yeah, and here because this drug is mixed with the bile acids and the gallbladder, and we consider the reabsorption as a delay. Right, now the mathematical model. And since we are injected a drug or administered a oral drug and it comes to the second compartment, so the concentration of drug in the second compartment is denoted by dx2 by dt. Yeah, and because we are injecting, or because we are administrating the oral drug, so in this we are taking d into delta t, and after entering into this, so this will be from this, the drug will be excreted from the other side K20, and which is not again coming to the central compartment, and excreted from this and entering into the central compartment K21, and it has a two excretions. So that's why we are taking this K20 and K21, and we are denoting this K20, K21 with a A, and we are taking this A, and it goes to the X2, and again after entering into the central compartment, again it comes to the second compartment, so X2T, and with the K2T mu of t minus tau into x1 of t minus tau. This mu of t minus tau represents the delay function. So this is the delay function, and which gives the delay because of the drug is mixed with the bile acids and in gallbladder. And in the first compartment, this is central compartment. In the central compartment, so an excretion is there. So K10 is one excretion, and another one is K12, which is reabsorbed by the peripheral compartment. So that's why we are taking this B is equals to K10 plus K12, and then the drug concentration or the plasma concentration entering to this one with a coefficient of K21. That's why we are taking positive K21 here. And initially there is no drug concentration in both the compartments. That's why we are considering it as x1 0, x1 at 0 and x2 at 0 is equals to 0. And now we try to solve these equations. And for solving these equations, we apply Laplace transformation on both sides, and which yields by equation 5 and 6. And we are getting two variables, so two equations. And solving for x1, Laplace of x1 and x2, we'll get the equation number 7 and equation number 8. And in these equations, we have c into e to the power of minus st is there. And this c is nothing but the product of k12 and k21. And then
so sir, please conclude.
Yeah, yes, sir. So to solve this one, we are applying inverse Laplace transformation. By applying inverse Laplace transformation, we get the equation for concentration of drug in the central compartment x1t, and we converted that into a series solution. And the interesting thing is in this series solution. So some cases, suppose if there is no reabsorption, so in that case, we are taking J is equals to 0. Then the concentration of the drug will be inverse Laplace of 1 by S plus A S plus B, which H naught T is nothing but 1 by A minus B into E power minus by T minus E power minus AT. Right. So if the reabsorption is there, so in that case, we will get the equation number 13. And this is usually when we are taking a oral drug, this happens always. Right. And for the second equation, and for the second compartment x2, and by applying the inverse Laplace transformation, and we get when there is only one absorption, then we'll get H naught T is equals to E power minus AT given by 16. And if the repeated absorptions are there, so in that case, we'll get the equation 17. And then the numerical solutions. So in the first compartment, because when drug is taken, it takes time to dissolve into the body. So that's why initially it started with something and it increases after dissolving. So the concentration will be rises, and it decreases because it is excreted from that, as well as it entering into the second compartment. But when it comes to the second compartment, directly drug entered, so the concentration is high. Then slowly with the time slowly the concentration will be decreases. Similarly, for the different values, we are taking the different conditions here. Yeah, right. And this is for the different concentration. And so in this model, the conclusion is in this model, so we introduce a delay between the reabsorption from central compartment to the peripheral compartment. And we observed, and our this numerical analysis supports our discussion. Thank you. These are some of our references. Thank you, sir.
Okay, thank you, sir.
For this opportunity.
Dr. Ravish Kumar ji. Ravish Kumar ji. I think he is not with us. So now I call next Lingaraj M. Angadi. Please unmute yourself. Yes, sir. Unmute yourself. Unmute yourself. Yes, sir. Sir. Hello.
Lingaram is unmuted now.
Yeah. Screen share is, I think. Hello. I think there is a problem. You are not audible. Hello. So I think, please, sir, I think your network is not good. Hello.
Ravi sir, please continue with
So
next participant.
Yes, sir.
Yes.
I call to NK
Hello.
Inegi.
NK Inegi. Yes.
Unmute yourself. Yes, sir.
Yes, sir. Thank you, sir. Hello. I'm
Yes, sir.
audible,
You
sir?
are,
Yes,
you
yes,
are
yes.
audible. You
Okay,
may
thank you, sir.
continue.
Yes, sir. Good afternoon, everyone. Can I start, sir?
Yes,
Okay.
yes.
Good afternoon, everyone. Myself, N.K. Engi, Assistant Professor of Mathematics, KRCS Society's Degree College, Bilingual, which is in Karnataka. I am very much thankful to the organizing committee of International E-Conference on Emerging Advances in Mathematical and Physical Sciences, organized by Department of Mathematics and Physics, Hindu College, Moradabad. With kind permission of the chairperson of this session, Dr. Ravish Kumar Yadav, sir, I am very happy to present a paper on the topic concept of convection. So can I share my screen, sir?
Yes, yes, yes.
1 minute, sir. I am sharing. Okay, thank you, sir. Can I audible, sir, now?
Yes, sir.
तिचं हे करून दिलं होतं बिल काढून दिलं होतं.
I'm happy to present a paper on this conference. My topic is,
माझ्याकडे आल्यावर मी 1-2 दिवसात करतो म्हटलं फक्त.
sir, some
please mute.
Yes.
Who is?
Please continue, please.
Okay, sir. Can I audible, sir, now? Can I continue?
Yeah.
Yes, I'm very happy to present a paper on the topic onset of convection in a coupled truss fluid saturated rotating Darcy-Brinkman porous medium. In this occasion, I am thankful to my guide, Dr. Krishna B. Chowreddy, and my co-guide, Dr. Sridhar Kulkarni. So, outline of my paper is abstract, introduction, geometrical representation of the problem, mathematical formulation, result and discussion, conclusion and references. So, as you know, so there are 3 modes of heat transfer. One is conduction, convection, and radiation. So, in that, so I am working on the second mode of heat transfer, that is the convection. So, linear stability of coupled truss fluid saturated rotating porous layer is determined when fluid and solid phases are not in local thermal equilibrium. And here we are use the Darcy-Brinkman model for moment equation. And we assume the bonding surfaces of a solid and fluid phases are identical temperature. And we study the effect of rotation. A Corral term is introduced in the moment equation. And Rayleigh number and critical wave number and effect of rotation, coupled truss parameter on the onset of convection is shown graphically. And we conclude then that coupled truss parameter C and the rotation parameter TA stabilize the system, whereas the conductivity ratio destabilize the system. So this is my abstract of paper. And the thermal convection is a fluid saturated porous media is a considerable interest due to the wide applications in chemical engineering, geothermal activities, oil recovery, and many practical applications. And most of authors well documented on this area. So now I move to the second, that is geometric representation of physical problem. Here, we consider the coupled truss fluid saturated rotating porous layer of depth here D, and we assume TL is the lower temperature and TU is the upper temperature, temperature at the upper surface, and we assume that the solid and fluid phases of the medium are not local thermal equilibrium, and we use a two-field model here. And of course, we heated from the below and cooled from the above. And this physical model is converted into mathematical model, that is the mathematical equations. So here equation 1, 2, 3, 4, 5 are the mathematical equation, that's the mathematical model. Equation 1 is equation of continuity, equation 2 is equation of momentum, and 3, 4 are the equation of energy, and 5 is equation of state. So here in equation number 2, so we have that non-linear term as well as the pressure term also here. So in order to eliminate those, we have to use the transformation equations. So equation number 6 is the equation of transformation. With help of this transformation, so we eliminate the pressure term here, delta P, and we convert that mathematical model to linearize, or it is a dimensionless. So after making dimensionless, we get equation 7, 8, and 9. 7 and 8 and 9. So when writing 7, 8, 9, so we have RA, that is a relay number, and gamma conductivity ratio, and H interface heat transfer coefficient, and TA Taylor number. So and alpha we have. So of course we making a non-linearized, we cannot solve by putting some conditions to this. So by using basic conditions and making so we get equation number 17, 18, and 19 by making perturbate, and we use some boundary conditions also, equation number 20, and by using to find relay number here, or wave number, so we use linear stability theory, which is equation number 21, that is W theta pi can be reduced or make change in terms of capital W and theta and pi, and here is it is a linear equation number 21, and after using this linear property, so we can express that mathematical model in terms of the matrix equation number 22. So by equating this equation number 20, that is the matrix equation to 0, so we get an expression array here 23, which is a relay number. Okay. Next, with the help of many mathematical programs, maybe Mathematica, Scilab, or MATLAB, so we can draw the graphs to analyze the problem physically. Okay. So now we move to this graph section. So this is the graph 1A to 1D here are neutral stability curves versus wave number for different values of here TA, that is rotation term, and gamma conductivity ratio, and couple truss parameter, and internal heat transfer coefficient. So in 1A, 1C, and 1D, the critical relay number here is increasing. When rotation is increasing, means the system becomes stable. That is, the relay number is increasing correspond to the rotation term here. That's of course it may be Taylor number. And in 1C also, relay number is increasing according as the couple truss parameter is increasing. And in figure 1D, so relay number is increasing according as this interface transfer coefficient H is increasing. Means, so 1A, 1B, 1C, so relay number is increasing according as TA, C, and H increases. That is, the system becomes stable. Whereas in 1B, so relay number is decreasing here when the conductivity ratio is increasing. Maybe the system becomes unstable. So next, in figure 2A and 2B and 2C, so it is a variation of critical relay number with interface transfer coefficient H for different values of TA, gamma, and H here. So again, so in figure 1A, relay number is, that is the effect of interface heat transfer coefficient here increases when rotation increases. Means rotation enhances the system. And as well as here couple truss parameter, the effect of interface heat transfer coefficient H here is that the corresponding relay number is increasing when the couple truss parameter is increasing. means the system becomes stable. And again, for critical Lilly number graphs, the conductivity ratio that destabilize the system. Okay, so in figure 3a, 3b, and 3c, so it is a variation of critical wave number, that is here AC against log H, means variation of critical wave number against.
Please conclude, sir.
Yes, sir. Yes, sir. It will be set on coefficient. Here, by observing all these graphs, that is the critical wave number is constant for small value of H and large value of H. Here, the small value of H and large value of H. So all these graphs, so that is the critical wave number is constant when H is small and large, of course. And in conductivity ratio, the value of gamma is not changed for small and large here, large value of H. That is the conductivity ratio is independent of this critical wave number. So when observing all these graphs, we conclude here the thermal convection is horizontal compressor saturated rotating porous layer is investigated analytically. It is found that the effect of increase of rotation is to increase the critical real number and critical wave number. Hence, the rotation parameter TA stabilize system, as well as the couple trace parameter also stabilize the system, but the conductivity ratio destabilize the system. Okay, thank you one and all. Thank you.
Okay, thank you, sir.
My opportunity to share my on this occasion.
Okay, sir. Dr. Ravish Kumar ji. So next participant, hello, Dr. Lakshminarayan Kundru. Please unmute yourself. Dr. Lakshminarayan Kundru.
He is presented already.
Acha, okay. So next is Rajesh Singh. Dr. Rajesh Singh.
Yes. Can you hear me?
Yes.
Okay.
Yes. Yes, please start.
So is my screen visible to everybody?
Yes. Yes. You
Okay.
have 5
so
to 6
good afternoon,
minutes.
everyone.
So please, you have 5 to 6 minutes.
Continue,
so
please continue.
Okay, sure. Okay, fine. Thank you. So good afternoon, everyone. I am Dr. Rajesh Singh, Assistant Professor, Department of Mathematics, Ramanujan College, University of Delhi. So first of all, I would like to thank the organizers of the conference for giving me an opportunity to present my paper on this platform. So I will be presenting my work on Graphidal length of a tree in terms of its diameter. So what are graphidal covers of a graph? So a graphidal cover of a graph is a collection psi of non-trivial paths, not necessarily open, such that no two paths in the collection have a common internal vertex, and every edge of G is in exactly one path in the collection. And the ordered pair G psi is called a graphidally covered graph, and the set of all graphidal covers of G is denoted by GG. So trivially, a path in a graphidal cover is called a psi edge of G. Set EG, members of which are paths of length 1 is trivially a graphidal G. A graphidal cover psi of a graph which is not equal to EG is called a non-trivial graphidal cover of G. So given any non-trivial graph and any graphidal cover psi of a G, we can associate a positive integer with G, which we denote by equal to minimum of length of the paths in graphidal cover psi of G. So we take any graphidal cover, then we take the length of all the paths in that graphidal cover, and we will minimize the length of the path. So the minimum length of the path is called length of the graphidal cover psi. So to each graphidal cover, we have associated a positive integer GL psi G, then we maximize GL psi G over all graphological covers of G. Then we get the parameter GLG, which is called graphological length of graph G. So it is maximum of all psi take over graphological covers, and then we minimize length of each path. So this is the example in which I have presented 3 different graphological covers of complete graph K4. So in the first graphological cover, we have a cycle of length 4, then 2 paths each of length 1. So minimum length here is 1. Then in the second graphological cover psi 2, we have 3 paths each of length 2. So minimum here is 2. Then in the third graphological cover psi 3, we have 2 graphological covers each of length 3. So in this case, the minimum is 3. And if we will try all the possible combinations of all the graphological covers of K4, then we will find that graphological length of K4 is equal to 3. So graphological length of a path is the original length of that path. That is, graphological length of path is n minus 1. And graphological length of a cycle is also the original length of that cycle. So graphological length of Cn is equal to n, and the parameter G is graph invariant. That is, it is same for all isomorphic graphs. So then I have obtained a bound for graphological length of a graph. So for any PQ graph G, GLG is less than or equal to the number of edges in the graph. If we take G not equal to, not isomorphic to path, then its graphological length is less than or equal to per IA counting graphological length of a tree. So first of all, I found bounds for graphological length of a tree. So for any tree T of diameter D, its graphological length is less than or equal to D, and equality if a tree is a path. If I treat a tree not isomorphic to path, then I could better the bound, and in the length of a tree, so the aim now is to characterize extremal graph for this upper bound. So I could characterize the extremal graphs, and this is the theorem. The tree type to a path and star, and its diameter equal to D, then its graphological length is K, where K is lying between D by 2 to 2D by 3. If such is size such a graphological cover, then so this, then for characterizing graphological length of a tree equal to 2D by 3, I have defined a new family of graph, which is T graph. In this case, I have denoted it by capital gamma M and K, and it is obtained by identifying dependent vertex of each path Pm plus 1, Pn plus 1, and Pk plus 1. So if you can see this graph gamma 2, 3, 5, so this is obtained by identifying a pendant vertex of each path P3, P6, and P4. This is the characterization of tree whose diameter is equal to 2D by 3. And it says that if T is a tree which is not isomorphic to a path, then its graphological length is equal to 2. Either T is a star with the order greater than or equal to 3, or T is isomorphic to T graph gamma M and K, where M and K satisfies the given condition. Then I could also characterize trees of diameter, because in this case I have not considered trees with diameter.
Please conclude, sir.
Equal to 4. So I have also characterized trees with diameter equal to 4 and not isomorphic to path. So in this case, graphology, if its n star u is less than or equal to 2 for graph, where n star u is defined as the set of vertices in the neighborhood of u, as that degree of V is equal to either 1 or V is support to 2 pendant vertices. The theorem which characterizes trees whose Gruffudd length lies between d by 2 and 2d by 3, and it says that Gruffudd length of a tree is equal to k, where k lies between d by 2 to 2d by 3 if and only if one of the following condition hold. First is that T is isomorphic to T graph gamma mn d minus m for some mn n greater than equal to n, such that k minus n is equal to m, which is less than d minus k. And second condition is T is isomorphic to gamma km d minus k for some m, such that 2k minus is less than equal to m, less than equal to d minus k.
Sir, please
So these
control,
are
sir.
the problems. I am whose Gruffudd length is equal to, second problem characterize tree whose Gruffudd length is less than equal to d by 2, because above d by 2 we have already characterized. So the problem is left to characterize trees whose Gruffudd length is less than equal to d by 2. These are some of my references. Thank you. So any questions?
Any question?
Any
Dr.
question
Ravi?
from the participant?
So please call next. Dr. Ravi Kumar ji,
Yes.
please call the next participants.
Okay. Next participant
Okay, so
is
should I finish?
Okay,
I
sir.
stop the
Kamalendra Kumar.
Kamlendra Kumar.
Kamalendra Kumar.
Kamlendra Kumar
Kamalendra Kumar is there.
नहीं है तो आप नेक्स्ट देखिए.
Next is
स्तुति
Stuti
श्रीवास्तव.
Srivastava.
स्तुति श्रीवास्तव.
Yes, sir, I'm here.
Yes,
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 yes.
yes. Okay.
Continue your
Okay, sir.
presentation. Please take on your screen.
Yes, sir. Sir, here, sir, it is written that host disable attended screen sharing.
Yeah.
Sir, screen sharing is, I think.
Oh, yeah, yeah.
So you are able
Dr. Dilip, please allow screen sharing.
Yes, yes, she is able.
Yes, you are able to share the screen.
Okay, sir.
Yes.
Just tick over the share option.
So, my
Just
name
tick.
is. Sorry.
दिलीप जी आप शेयर कर दीजिए इनकी स्क्रीन.
सर क्या करूँ मैं?
Please continue. Now you are on screen.
Okay, sir. Okay. Okay. Good afternoon, all. My name is Stuti Srivastava. I'm a PhD research scholar from the Albach Educational Institute, Agra, and my topic of presentation is a heuristic approach for bandwidth coloring problem. So, okay. First of all, let me introduce what is bandwidth coloring problem. So we all aware of graph coloring problem, which was arrived in 1852, when the problem arrived to color a map of a country of England by using just 4 colors. And then later, after this, vertex coloring problem arrived, in which we have to color vertices of a graph such that the 2 adjacent vertices do not receive same color. And after that, bandwidth coloring problem is a generalization of graph coloring problem or vertex color problem, where one more constraint is added, so that we have to assign colors to all vertices of a graph, such that the difference between 2 vertices is more than the edge between these graphs. In mathematical form, suppose we have a graph G is equal to V comma E, where V is the set of vertices and E is set of edges. Yeah. Okay, then we have to assign colors to V, where CV is the color of vertex VI and CVJ is color of vertex VJ. So that the difference between these two colors should be greater than equal to D of VI VJ, which is difference between which is edge weight of the edge weight of the edge between these two vertices VI and VJ. And our problem is to minimize the maximum number of colors. So this problem has many application in frequency assignment problem, like in mobile telephone, television, satellite communication. Suppose we want to assign different frequencies to different radio channels, and we want that there should not be any interference between the frequency of two radio channels. So what we will do, we will assign some weights on we will maintain the frequencies by some distance. So by using bandwidth coloring problem, we can solve these problems. Here are some literature reviews. Some meta-heuristic approaches has been developed for this problem, like taboo search based approach. Then in 2010, three genetic algorithms was proposed for this problem. Then in 2014, a path linking approach, and later on in 2016, they also proposed another method for this problem. So these are some methods.
Thank you.
Oh, okay. The contribution of my paper is I have proposed a greedy coloring algorithm. Greedy coloring heuristic for this problem. This heuristic consists of two phases: a construction phase and a coloring phase. In construction phase, I have also developed 4 different approaches, and then after this greedy algorithm, I have experimented on 33 well-known graphs to compare my results.
Thank you.
So,
Okay. Thank you. So next participant, Aruna. Okay.
Yes, Dr. Aruna.
Dr. Aruna Madhukar Kulkarni.
Yes.
Yes, ma'am. Please.
Continue your presentation, please.
So shall I continue?
Please.
Good afternoon, all. Myself, Aruna Kulkarni from Maharashtra. I am going to present my article towards a simple and secure method for cryptography via one-to-one mapping. Introduction to this article.
Yes.
This is outline. In the present age of electronic communication, we have to keep the communication.
Share your screen.
Is screen visible?
No. Please share your screen. Share screen option. Share screen
you have
option.
Some text, then share in your own screen.
Yes. Now it is visible. Okay.
Okay.
Please
I am going to present my article.
Yes. Okay.
Introduction to this article. In the present age of electronics communication, we have to keep the communication private. Cryptography mainly consists of encryption and decryption. Encryption is the transformation of data into some unreadable form, while decryption is exactly the reverse process of this. So this is the outline for this article. Objective to this, to demonstrate and explain how encryption and decryption of messages work using one-to-one mapping and its invertible mapping. So method of decoding. A one-to-one mapping f of x is equal to 5x plus 3 mod 26 is a key mapping, also known as secret key. This key is used to encrypt the message, and decryption of encoded message is carried out by using invertible mapping g of x, which is the invertible mapping of inverse of f of x, where g of x is given as g of x is equal to ax plus b mod 26. By an interesting task, the values of the constants a and b are determined. Now, here the example is given. Suppose we want to send the message, water is life, treat it right. And the encoding mapping is f of x is equal to 5x plus 3 mod 26 for all x belongs to the set 0 to 25. Then next, what to do? Now associate each letter with its position in the alphabet. A is 0, 1 is, B is 1, C is 2, and so on. Lastly, Z is 25. Thus, our message is water is life, treat it right, and give that number associate with that letters. That is W stands for 22, A stands for 0, T for 19, and so on. Lastly, that H for 7 and T for again 19. Now what to do? Take our that is the key of key function of our key function f of x is equal to 5x plus 3 mod 26 and calculate the values associated with our letters of the message. So first calculate f of 22 is equal to 5 into 22 plus 3 mod 26, that is 113 mod 26. We get that is equal to 9. In similar way, we calculate f of 0 equal to 3, f of 4 is equal to 23, and so on. F of 4 is equal to again 23, so on. Then the original message is converted as this unreadable form, that is JDUXK, giving this values of f of x. And this message unreadable form is known as the encoded message. This is also known as the ciphertext. This message, unreadable message, receives the receiver. Then receiver has the decoding key. It is our decoding mapping. It is given by g of x is equal to 21x minus 11 mod 26. With the help of this, received message is denoted by finding the values of g of 9, where that received message is converted to again numerical string, and we get that string as 9, 3, 20, and so on. Then the values of g of 9, it is find by 21 into 9 minus 11 mod 26, that is 178 mod 26. We get 22. Similarly, g of 3 equal to 0, g of 20 is equal to 19, and so on. Lastly, we find all values. G of 10 equal to 17, G of 17 equal to 8, G of 7 equal to 6, G of 12 equal to 7. Lastly, G of 20 equal to 19. And this message is converted again, this string, we get this numerical string, that is 22, 0, 19, 4, 17, which gives the word water. Then next it is water is life, treat it right. Thus, we get our original message. From this, we conclude that distinct types of mappings are also used to generate key mapping to increase the security of text communication. The improvision of ciphertext becomes relatively more secure due to utilization of quadratic form of mapping. Different types of mappings are well-known tool for storage of huge data. In this article, very simple encryption technique has been presented in order to make familiar with the various encryption schemes used in encrypting the data using different mappings. Every scheme has advantages and disadvantages based on their techniques, which are mainly based on finding the inverses of key mapping. So these are the references for this article. Thank you. Thank you very much.
Okay, thanks.
Okay, thank you. Thank you, Dr. Arna. Next participant is Vikas Popli.
Yes, sir. Yes, sir. Yes, sir. I am. Are you?
Join, please. Please join.
Sir, I am sharing my screen.
Okay.
Yeah.
अवनीश जी
झालं तर माझं काही दिसत नाही कसं बरं केलं जरा
Sir, is the screen is shareable?
Okay, share.
Yeah.
Share
Yeah,
your
it is your,
host
you are
space.
in
काय
screen.
असेल त्याचं
Yes, sir. Good afternoon to all of you. Myself, Dr. Vikas Popli, Assistant Professor in Department of Mathematics, Kishanlal Public College, Rewari. And firstly, I am very grateful and thankful for the organizers for such a great e-conference for the participants and the research scholars. Now, my topic of the study is impact of oblique MSD flows on flow and heat transfers over stretching sheet and shrinking sheets, basically. Now, what is the stretching and shrinking sheet here? When we in the industrial and manufacturing processes, what we have to do, we have to make the polymer extractions, the wire dryings in this type, in these surfaces, in these processes, we have to make the sheets sometimes stretch and sometimes shrink. So what we have to do is we have to control the rate of heat and mass transfers to get the better quality of the product. Now, outline of my presentation is introduction, but where I got the motivations from this study, physical model of for the oblique flow, material and methods, the numerical procedures, results and discussions, conclusion and references. Now, why we are using stretching and shrinking sheets? I am earlier explaining that for getting the better results of the product in manufacturing and engineering processes, in metallurgical process, why we need magnetohydrodynamics flows to control the rate of heat and mass transfers, and why we need oblique flow to control the rate of heat and mass transfer in magnetic flows. To get the better quality of results, we need the oblique flow. Now, basically the practical importance of this particular study motivate me to these studies, to boundary layer flow control, heat removal from the nuclear plant, radioactive waste materials in high temperatures, radioactive nuclear plants, and in geophysics and space technology, petroleum engineering. When I talk about the particular applications of this study, it is used to create polymers, casting glass fibers, metal extrusions, wire drying, aerodynamics shapings, and MSD flows has importance in heat exchange, metallurgical process, electronic equipment, and some nuclear reactors. These are the best applications of the MSD and oblique flow. Now, the physical model of my oblique flow is we are taking a shrinking and stretching sheets along x-axis, and flow is impinging obliquely on the sheet to control the heat transfer rate over which is going through the sheet, and a magnetic field is applied to control in a better way to get the desired quality and shape of the results. Now, material methods, basically we use the Navier-Stokes equations of heat. The equation number 1, 2, 3, 4 are the continuity, momentum, energy, and concentration equations. Basically, in an oblique flow, we are taking two momentum equations, equation number 2 and equation number 3, which is because when we use the oblique flow, the flow flows in the two directions, x and y. So we are taking the two equations here and the corresponding boundary conditions. And the numerical procedure is very good explained by the Inagi sir. We will not solve the directly ordinary partial differential equations. So we have to convert the ordinary partial differential equations into ordinary differential equations to get the better quality of the result. to get the solution of the equations. So we need the similarity variables to solve these equations, and after solving this, we will use MATLAB or other softwares to numerically program this, and we get the results. Now, I am here explaining the two results of MSD flows. When we increase the magnetism in the flows, it is shown by the figure. That is, when we increase the magnetism, a Lorentz force exerts in the systems, and a Lorentz force retards the flow. It means it opposes the flows of the motion. So the fluid velocity decreases when we increase the magnetism, increase the magnetic field on the system, and when the flow velocity reduces, so we get the a control on the rate of heat transfers. Now, when we go next, the effect of magnetic field on the heat transfer rate. When the fluid velocity increases, fluid velocity decreases, the rate of heat transfers in the fluid increases, and shown by this figure by the arrow sign. And the conclusions that the computed outcomes of the governing equations is the velocity declines and the temperature rises with the increase in the M. And these are some references which I used for my presentations and my paper. And it is very, very much useful for the magneto-hydrodynamic flow in industrial applications to get the better quality of the results. Thank you.
Okay, thank you, sir.
Any questions?
No, sir.
Okay, questions are welcome from the participants also.
Okay, sir. Next.
Next is B. Shiva Naglu Malleshwar.
B. Shiva Naga Malleshwari.
Malleshwari है.
B. Shiva Naga Malleshwari here. Hello. B. Shiva Naga Malleshwari. Now I call to Dr. Gauramma A. Godagi. Dr. Gauramma A. Godagi.
Hi.
Yes.
Madam, solve very well.
Okay, okay.
Dr. Arvind B. Deshi.
नहीं ये आ गई ना.
अच्छा हो गई.
Yes.
Good afternoon, everyone.
Yes.
डॉक्टर लिंगराज मंगाड़ी.
नहीं वो बाद में होगा, अभी नहीं. ये जो हो रहा है उसको करने दीजिए सर.
Teaching assistant, Department of Mathematics, Kelly G.I. Bagawadi, Arts, Science and Commerce College, Nippon.
Any other participant?
Ma'am, your voice is too low.
Yes.
Let G be the simple connected graph of order n, size m. In this paper, we define degree exponent dE, matrix whose I, jth entry is dith power dj if vi and vj are the adjacent and 0 is the other cases. The degree exponent energy of G is the sum of absolute values of dE of G. Here we present our results on D polynomial and DEE of different graph classes. Introduction. Thought this paper, G will be denote a simple undirected graph with the n vertices and m edges. Let V1, V2 and so on up to Vn be the set of vertices of G.
Please share your screen.
I think she is not able to.
Madam, share your screen, madam.
Okay.
Yes, yes.
Start video.
Okay.
ಇಲ್ಲಾಂದ್ರೆ ಹಿಂಗ್ ತಗೊಂಡ ಇದು ಮಾಡ್ರಿ
ಮೇಡಮ್ ಸೇರ್ ಕ್ಲಿಕ್ ಮಾಡ್ರಿ ಮೊದಲ
ಹಾ ಸರ್
ಸೇರ್ ಆಮೇಲೆ ಸೇರ್ ಅಂತನ್ರಿ ಬರ್ತದ ಸ್ಕ್ರೀನ್ ರೀ ಹಾ ಬೆಟ್ರಿ ಸರಿ ಮೇಡಮ್
It's directly to go with the
Yes.
next theorem 1. Let G be an R regular graph on n vertices, then the DE characteristic polynomial of G is DEA of G comma lambda is equal to R to the power NR into pi of G comma lambda divided by R to the power R. By using that, next corollary, the degree exponent polynomial of the cycle graph is how to prove this result. Next. Using this theorem, by using this theorem, we have to prove this corollary. For n is greater than or equal to 3, the degree exponent characteristic polynomial of the cycle graph Cn satisfies DEA of Cn comma lambda is equal to lambda into lambda n minus 1 minus 32 lambda n minus 2 minus 2 to the power 2n plus 1. Next theorem, for n is greater than or equals to 5, the degree exponent characteristic polynomial of the path graph satisfies DEA of Pn comma lambda is equal to lambda square into lambda n minus 2 minus 4 lambda into lambda n minus 3 plus 4 lambda n minus 4. For every k greater than or equals to 3, lambda k is equal to lambda into lambda k minus 1 minus 16 lambda k minus 2 with lambda 1 is equal to lambda and lambda 2 is equals to lambda square minus 16. In this matrix, next theorem, for any positive integers p comma q, the degree exponent polynomial of the complete bipartite graph k p comma q is DEA of k comma p comma q comma lambda is equals to lambda to the power p plus q minus 2.
Okay, ma'am, please conclude it.
Hence, it prove this theorem. For n is greater than or equals to 2, the degree exponent polynomial of a friendship graph of d4 to the power n is DEA of d4 to the power n comma lambda is equal to lambda to the power n plus 1 into lambda square minus 32 to the power n minus 1 into lambda square minus bracket of 32 plus 8 n cube into 4 to the power n. The line graph of the G denoted by L of G is the graph whose vertices corresponds to the edges of. We have proved this theorem. If G is a regular graph of order n of a degree r, then the degree exponent eigenvalues of L of G are. And also proved this theorem, if G is a regular graph of order n and degree r is greater than or equal to 3, then the degree exponent eigenvalue LG of LGR is equals to nr into r minus 1 whole divided by 2 minus of bracket 4r minus 5 minus lambda I minus r plus 5, where I starts from 2, 3, 4 and so on up to finite number.
Please conclude, ma'am.
The references.
Okay. Thank you.
Thank you, sir.
So, Now, Dr. A.V. Desi, please unmute yourself.
Yes, sir.
Yes.
Am I audible?
Yes, yes.
Hello. Hello.
Yes, yes, you are audible.
Am I audible, sir?
Yes, yes.
Yes, yes, you are. Welcome.
Please share your screen.
Okay, sir. Good morning, everybody. Myself, Dr. Arvind B. Desi, Assistant Professor, Department of Mathematics, KLA College of Engineering and Technology, Chikkodi from Karnataka. First of all, I would like to thank to the organizers for organizing this conference and allow me to present my research work. Thank you, one and all. Now, I will present my research work, the entitled The Numerical Solution of Elliptic Partial Differential Equations Using Bi-orthogonal Wavelet-Based Multigrid Method. Abstract of this paper is, recently wavelets play an important role in significant interest from both theoretical and applied researchers. Here we propose the numerical solution of elliptic partial differential equations using bi-orthogonal wavelet-based multigrid method. The performance of the proposed scheme is better than existing ones in terms of superconvergence with low computational time. Some of the illustrative examples validate the applicability of the method. These are some introduction. We'll skip this one. Directly, we'll go to using the Siraj-Shetty et al. Proposed the bi-orthogonal wavelet-based full approximation schemes for the numerical solution of EHL problems and parabolic partial differential equations. In the same work here, we consider and introduce restriction and prolongation operators, respectively, using these decomposition and reconstruction matrices in the implementation of bi-orthogonal wavelet multigrid method for the solution of elliptic problems. These are the introduction for bi-orthogonal wavelets, and using bi-orthogonal filter coefficients, the bi-orthogonal discrete wavelet transfer matrix is defined. This is of n cross n. This is a decomposition matrix. The next one is reconstruction matrix. But using that bi-orthogonal discrete wavelet transform, we modified that matrix, called it as a modified bi-orthogonal discrete wavelet transform matrix, which is by adding rows and columns consecutively with the diagonal element as a one, in which we have new decomposition matrix which is different from the previous one. And similarly, we have the new reconstruction matrix. Using these matrices, we introduce a new restriction and prolongation operators, respectively, like multigrid restriction and prolongator operators, and the detailed procedure explained in the method of solution. Now, we have the method of solution. Consider any differential equation. After discretizing the differential equation using finite difference method, we get the system of equation AU equal to B, where A is a n cross n coefficient matrix, B is n cross 1 matrix, and U is n cross 1 matrix, which is to be determined. Solve equation number 1 through any iterative method, we get the approximate solution V of U. But U is E plus V, that is E is a error which is to be determined. In the numerical approximation, approximate solutions containing some error. There are many approaches to minimize the error. Some of them are multigrid method, bi-orthogonal wavelet multigrid method, and modified bi-orthogonal wavelet multigrid methods. Now we discuss the method of solution, and multigrid method is already existing ones. In that multigrid method, we use reconstruction operator as a R and prolongation operator as a P. But use that method in our using these restriction and prolongation operator, that is bi-orthogonal wavelet multigrid method, using the same procedure as in explained in the case of multigrid method. Instead of using R and P matrices, we can use the bi-orthogonal wavelet multigrid operators as a BWR. This is like as a R, and this BWP is like as a prolongation operator P, and this is modified by orthogonal multigrid method. Here also the same procedure as applied in the previous case. Instead of using R and P, that is restriction and prolongation operators, we can use new bi-orthogonal multigrid integrals, that is new bi-orthogonal wavelet restriction operator, that is NBWR instead of R, and NBWP instead of P. Using these matrices, now we consider the simple example, that is first order differential equation, equation number 3, subject to the boundary conditions. And according to the procedure explained in the method of solution, we get the solutions and comparing these results in the figure and table. In the figure 1, all the methods with the exact equation are already coincide, but in the table, the first row is finite difference method, the second row is multi-grid method, the third row is bi-orthogonal multi-grid method, and the fourth row is modified bi-orthogonal multi-grid method. See the last column, this is the computational time. In our bi-orthogonal multi-grid method, the computational time is very less compared to the previous FDM and multi-grid method. This is up to the up to 256 points. Now we consider the second order elliptic partial differential equation, equation number 4. Similarly, as explained in the method of solution, we have the solution compared with the exact and multi-grid method. All the solutions are coincide with each other. Similarly, we have the table for the comparison of computational time, FDM, multi-grid method, and bi-orthogonal multi-grid method, and modified multi-grid method. Here also considering the last row.
Okay, conclude, sir.
Okay, sir. In this paper, we have proposed an efficient bi-orthogonal based multi-grid schemes using wavelet integrated operators based on bi-orthogonal wavelet filters coefficients for the numerical solution of elliptic partial differential equation. The proposed schemes formulated and have the following characteristics. The method possesses superconvergence properties. The method incorporates boundary conditions in a systematic fashion. Observations from the figures clearly seen that presented solutions are coincide with the exact one. The numerical implementation from the table demonstrate the accuracy of approximation and superconvergence phenomenon in less CPU time. Hence, the proposed scheme is very convenient, efficient, and has wide applications in the field of science and engineering. And these are my references.
Okay.
Especially, this paper is referred from reference number 17 and 18.
Okay,
Thank you.
okay.
Is there any questions, sir?
No.
Okay, thank you. Thank you very much.
Now, Dr. Sridhar. Sridhar. Hello. Sridhar. Dr. Sridhar. Hello. Are you there? Any more participants who wants to present, whose name is there?
Yeah. Dr. Lingaraj M. Angadi.
Hello?
Yes.
Hello.
Sridhar is online, sir.
Okay, okay.
You have
start.
present your paper?
Yes, start.
Please start.
On who is?
Okay.
Para Manjula.
No, I will be ready, sir.
Yes, ready. Okay.
Sir, shall I do, sir? Upara Manjula?
No. First Dr. Sridhar. Dr. Sridhar.
Hello, sir.
Yes.
Is the screen is visible, sir?
Your
Hello?
name is there. Your name. Screen. Share your screen.
Common fixed point theorems.
Your screen is not visible yet.
Screen is not visible, sir?
No. Share your screen.
Sharing. I will share the screen, sir.
Yes.
Screen share. Now?
Yes.
Now visible, sir, screen?
No.
Visible call as under screen.
2 minutes.
Okay, sir. Okay, sir. 1 minute, sir. Now visible, sir, screen?
Yes, yes.
Okay. Common fixed point theorems in fuzzy metric space, sir. My paper is.
Yes.
It is jointly with Sridhar and S. Srilata, sir.
स्क्रीन नहीं आ रही आपकी, स्क्रीन नहीं आ रही अभी।
Screen नहीं आ रहा अभी, sir, अभी?
No, your screen is not visible yet.
Okay. I will adjust, sir. I will adjust. And I know. Malok, sir, adjust the screen. I know. Please adjust. Hello.
Yes, hello, बोलिए।
Okay, I am adjusting, sir. I am adjusting the screen.
Okay.
Now visible, sir, screen?
No, not visible yet.
Please present your side as it is, जैसे आप कर रहे हैं वैसे ही करिए। छुट्टी करिए।
Now visible, sir, screen?
No. रीड करा दीजिए सर orally.
Okay, I am trying, sir. 1 minute.
Dilip sir.
Yes, Dilip sir, please share his screen.
Now visible, sir? Hello?
Yes, आपकी ये स्क्रीन यहाँ से विजिबल हो रही है। अब आप इसे पढ़िए और इसको बता दीजिए।
Common fixed point theorems in M fuzzy metric space, sir.
Yes.
It is along with the two others, sir. C. Sridhar, S. Srilata, sir. We are from Andhra Pradesh, sir. We are from Andhra Pradesh, sir. Okay. The main object of the paper is we proved a fixed point theorem in M fuzzy metric space using weakly commuting mapping, sir. The concept of fuzzy set was introduced initially by Jade in 1965, sir. In 1992, Day introduced the concept of D-metric and studied fixed point theorems. Almost all theorems of Day are not valid. Sedgwick and Shobe introduced D-star metric space. Is it audible, sir?
Yes,
it is audible.
Continue, please.
Okay, by altering the tetrahedron inequality in D-metric. Use the D-metric analogy, M fuzzy metric space is introduced and proved many fixed point theorems in M fuzzy metric space. So, first definition is, it is a binary operation, T maps 01 to 01, 01 to 01, which is a continuous T norm. It satisfies the following conditions. One is T is associative and commutative. T is continuous and T of A1 is equal to A for all A belongs to 0, 1. T of AB less than or equal to T of CD whenever A less than or equal to C, B less than or equal to D. Actually, D star metric space, these are the four conditions in the triangular norm or T norm. Okay, sir. The next definition is definition 1.2. A three-tuple XMT is called a M fuzzy metric space if X is an arbitrary non-empty set, T is a continuous T norm, M is a fuzzy set on X cube cross 0 to infinity, satisfies the following conditions. For all XYZ A belongs to X and S comma T greater than 0, it has the four conditions. Fuzzy metric space 1, M fuzzy metric space 1, sir. But these are the M fuzzy metric space definition. It was introduced by, hello.
Sir, please अपना जो भी result है उसको आप बताइए.
Okay, sir.
Your
Okay.
results.
Okay, sir. Okay. So these are the definition of, this is the definition of M fuzzy metric space. It contains the four conditions. Okay. Along with these two definitions, next to the lemma 1.1 we are using, sir. In the lemma 1.1, it is just a generalization of a symmetric property. M of xxyt is equal to M of xyyt. It is generalization of symmetric property. It is more useful to solve the main theorem. And the another one is M of xyz dot is non-increasing, sir. Non-decreasing. Non-decreasing means it must be the increasing function. It must be the increasing function. And one more thing is the fuzzy matrix space should contain the Cauchy sequence condition. The Cauchy sequence condition which satisfies the follow, it satisfies M bracket xn plus 1 knt, and by doing the triangle, by doing the condition of M fuzzy matrix space, and by that you will get M bracket x0 x0 x1t. By getting this one, you say that xn is a Cauchy sequence. So this is the main result, sir.
Okay.
The main result is PQABSTB self-mappings of a M fuzzy matrix space. So we are taking the 6 mappings in the fuzzy matrix space, which should contain the M of the contraction condition, sir. M fuzzy matrix space contraction condition, M bracket Px Qy Qy Kt greater or equal to M bracket ABX STY STYT star M bracket PX ABX ABXT star M bracket PX STY STYT. The third second condition is P
सर
of
ये
X sub. Sir.
सर ये रिजल्ट तो हम लोग सब देख ही लेंगे बाद में, आपका जो मेन कंक्लूजन है वो सब बताइए, क्योंकि हमारा टाइम भी हो रहा है ना सर.
Sir, by doing this, we will get a fixed point, sir. Sir, by doing this, we will get a fixed point in the M fuzzy matrix space, sir.
Yes.
By doing this, we will get a, and actually, what happening that, sir, first we take the 2 mappings, sir. For 2 mappings, we take a sequence, sir. For 2 mappings, we take a sequence. The 2 sequence is one is the even sequence, the another one is the odd sequence, sir. So y naught equal to px naught stx1. This is an even sequence, sir. Y1 qx, and this we write in the generalized manner. Then you will get the yn in x has become y2n plus 1 2n plus 1, sir. With this y2n plus 1, we make the fuzzy matrix space, sir. That fuzzy matrix space in terms of sequence, sir. That is M bracket ym mm plus 1 m plus 1 m plus 1 t.
Okay,
And
sir.
this is sir.
Okay, sir.
This,
okay, please.
Okay, na, sir.
Now
Okay,
complete.
sir.
Okay, thank you, sir.
Thank you, sir. Thank you.
Okay. Now, Uprala. Hello.
Yes, sir.
Okay.
Any
Start.
questions, sir?
No. Please start your.
Yes, sir. Yes, sir.
Yes.
1 minute, sir. 1 minute.
Yes.
Visible my presentation, sir?
Yes. Please start.
Okay. Good afternoon, one and all present here. So today I'm going to discuss about my paper, that is the eta parallel pi tensor in of real hypersurface of a complex space form. So first I'll start the introduction.
Please conclude in 5 minutes.
Okay, sir. 1 minute.
Okay.
So these are 6 definitions. So I'll not discuss because there is no time.
Okay.
So next here discussing about the hypersurface of a complex space form. That means these are the basic equations. That is the structural tensor satisfy the following equations. So now next the Gauss and Kodazzi equations are using here. That means the curvature tensors we are using. This is the main curvature tensor, equation 4. From equation 4, I'll reduce to as a Ricci operator, Ricci tensor and scalar tensor. The 6 and 7 are the Ricci tensor and scalar tensors. From that 4 and 6, 7 using to solve the results. That are, first result is if a real hypersurface of a complex space form is of surface with principal curvature alpha, then alpha is a trace A. That means I'll take here tensor pi is a eta parallel. So that is the del x pi y comma z. Del x pi is there now. So that one we have to use to simplify that it is the trace of A. So here in equation 12, I'll substitute equation 2. So next after substitution, we'll get this 13. Next, I'll take is z equals to z, substituting 13. So I'll get it the alpha eta of x, eta of y minus g of ax comma y equals to 0. From this equation, so I'll write down this principal curvature alpha. That means alpha equals to trace of A. So this is the first theorem I proved. Next, I'll start second theorem. So here in this theorem, I'll using the Ricci-Soliton special one, that is equation 11. So this is the Ricci-Soliton. From this Ricci-Soliton, I used to prove pi a equals to e pi. That means first I'll take equation 11. From that equation 11, substitute equation 3. It is reduced to like 13. Equation 17. From 17, I'll substitute in 11. That means again I used to substitute Ricci-Soliton and reduces to your this equation qx equals to lambda minus half into pi a minus a pi. From this equation to prove it is the Ricci-Soliton lambda, constant lambda is the eigenvalue of a Ricci operator. So next theorem, I'll start next theorem. That is a real hypersurface M of a complex space form is of hypersurface with the principal curvature alpha equals to of trace of A, or provided trace of A is not a constant. Here we are not consider it is not a constant. In the previous theorems we will take it is a constant, but in this theorem I'll not use to take a constant. So again I'll use equation 7, that is scalar curvature. From that curvature to reduce equation 20. From this equation 20, I'll use to substitute EI, x equals to y equals to EI, and it reduces to your equation 21. Next, again I'll substitute W and x equals to EI in this equation, this equation 20. So it is reduces to Az equals to Az into H equals to half into xi H into H. So this is the
Okay.
Yeah. So these are the references.
Okay.
These are the references. Thank you, sir.
Thank you. So I think anyone whose name is in today's schedule is there? Anyone whose name is today's schedule is there? Please raise your hand.
Hello.
Yes.
Yes, sir. I am Dr. Natasha.
Your name is in mathematics?
In physics, sir.
No, so you join the Google Meet. There is a presentation on physics.
Right now?
Yes.
Okay.
Please go there. Okay. So I think there is in this group no more presenter. Now I want to hello Dr. Ravish Kumar ji.
Yeah.
Please give your remark. Please give your remark and conclude. I think there is no presenter now.
All participants present their paper. Anyone?
No, there is no participant. So I think.
Hello.
हेलो हो
हेलो
गया खत्म?
हाँ डॉक्टर रवि राकेश जी हेलो
Okay, so thanks to all the participants, and we will leave and we will join tomorrow at 11 o'clock. So thanks to all the participants and presentators who have joined the conference once again.